you can protect all of them with just one product. So this is the first and only enterprise-grade protection solution for virtual machines, applications, and Kubernetes. And we are really excited to talk about it today. So just to give a brief overview of PowerProtect and our integration with Tanzu. So currently we can support VMware Cloud Native Storage. So what that means is when you have a VMware a storage environment with Kubernetes running on top and you're leveraging the VMware Cloud Native Storage that's exposed to the Kubernetes environment, we can protect those using special APIs that we have worked with VMware. Secondly, you can run either your Tanzu Kubernetes grid, that's TKG, formerly known as Essentials PKS, or your TKG integrated or TKGI solution on the VMware environment, or any other Kubernetes environment such as OpenShift or Anthos that leverages VMware Cloud Native Storage on the VMware environments. You can protect it using PowerProtect. So technically, any distribution of Kubernetes that can leverage the VMware Cloud Native Storage can be protected using PowerProtect Data Manager. And here's the exciting part, right? So we are currently actively working on with VMware to protect guest clusters. So what that means is when you have project-specific based environments, so which allows you to create these special namespaces that allows you to run Kubernetes and virtual machines and native pods all side by side in the same namespace, you can protect them all using PowerProtect Data Manager. And this feature we are expecting to be releasing around the Q4, and we are actively engaged with VMware to protect this. So this gives you a very integrated solution. So for your IT, as your IT team is moving to project specific and you need a enterprise grade solution to protect that entire environment, you need to look no further. PowerProtect Data Manager can protect it all. Another feature that we currently have with our current PowerProtect Data Manager releases, you can protect your AWS workloads. That is, if you're running Kubernetes environments on AWS, you can protect them. We currently have DDVE currently available on AWS, and that allows you to protect all your Kubernetes environments and containers running on EBS, which is the AWS block storage, and you can protect them directly to DDVE. And the good part is that the PowerProtect Data Manager can run inside AWS, or it can be, technically it can run anywhere. It can run on your on-prem environment. It can be on another private cloud. Doesn't matter where the PowerProtect Data Manager runs. It can run and manage your entire AWS clusters from virtually anywhere. Now, this brings up to the challenges that we have. Now you have multiple Kubernetes environments, as we see a lot of organizations today having multi-cloud solutions. If you have multiple Kubernetes environments running on-prem, maybe on VMware or on AWS or on Azure or other cloud vendors, and then you want to replicate data across all these clouds, that's a huge challenge. I mean, it reminds me of the scene from the 36th Chamber of Shaolin, one of my all-time favorite kung fu movies, and in which scene the hero has to carry huge buckets of water across a very thin, narrow bridge with knives attached to these armpits. And that's very similar to the pain that we are currently seeing IT teams having to move S3 buckets or like huge amounts of data across different clouds. And without an efficient deduplication, a compression, and efficient replication, you are essentially transporting huge volumes of data across multiple clusters. So what this will do is going to cause delays in terms of hours, weeks, and months to replicate. When you're talking about petabytes, maybe terabytes of data, you'll be unable to meet the SLAs. And finally, the egress costs equivalent to the knives on the armpits, right? So they're going to cut you, and they cut your organization budget. So what you need is a very efficient solution that can help with replicating data across the cloud. And that's the challenge that we have undertaken as part of our solution. that with PowerProtect Data Manager, we are hoping to today manage your Kubernetes environments across multiple clouds. As we talked about, we can currently support vSphere. We can support AWS today. We are adding additional capability to support other clouds pretty soon. And also we are allowing the capabilities to support a diverse array of protection storage, which includes your data domain, the object store that you currently have, or data domain virtual edition. And all of this combined to allow you to replicate across sites, tier to object, and to support secondary use cases. So regardless of where your Kubernetes environment is, whether it's in the data center or the cloud or the edge, we can protect all of them and provide synchronized enterprise-grade policies, providing dedupe and compression, application consistency for a wide range of databases in the Kubernetes cluster. In addition, providing replication, cloud tiering, SLA compliance reporting, and also centralized, and most importantly, a centralized protection for not only your Kubernetes environment, but also for the VMs and apps. So all in all, this is a complete package to protect all of your enterprise needs. And here's a quick look at the architecture for how we are going to protect your Kubernetes environments on VMware, right? So with PowerProtect Data Manager, when we discover clusters, we install a couple of namespaces. So there is the Velero namespace here. Velero, again, the open source solution, currently sponsored by VMware. And when we have a PowerProtect namespace, which is our components that we have developed here at Dell. And together, we will be protecting our applications. And we take snapshots using the VMware's exclusive partnership that we have with VMware to take cloud native storage or FCD snapshots. So what this results in is you get incremental snapshots, not like full snapshots, and all of them highly deduplicated and compressed and highly efficient to move it to your backend storage. And that's easy. So now you have, instead of having huge volumes of data, you're having very small amounts of data being protected back in your protection storage, so your footprint doesn't grow, and all this data can be easily replicated and migrated across multiple clouds or wherever your digital transformation projects lead you. So I'm really excited about talking about our PowerProtect Data Manager and our product and journey. For additional details, please visit our website, and thank you for watching.
Hey, this is Shashi. I am from PowerFlex product management team, and I focus on developing applications and workload solutions with PowerFlex. In today's session, I'm going to talk about enterprise databases on containers, specifically with PowerFlex and VMware. So let's go through some of the specific data points as why enterprise databases on containers. So a recent study by Gartner predicts that by 2022, more than 75% of global organizations will be containerized. Again, this is very, very predominant for database deployments also, as database customers are looking for kind of flexibility and then also kind of speed and also some of the key benefits which they can get while deploying containers. And then also some of the other benefits, as you can see, is the startup for container-based deployments will be in the milliseconds. And then there are a lot of advantages with respect to cost and then also with respect to the speed of the deployment. So, and then also for a lot of customers, again, there is always a question, especially for customers who have already invested and then have standardized on virtual infrastructure. There is always a question, should I do virtualization or should I do containers only? Or is there a benefit of deploying containers on top of virtual machines? So this question, again, the answer to that is definitely yes. There are a lot of benefits of deploying containers on top of virtual machines. The specific, probably I will highlight one or two big reasons. One is the security. And then also the other specific reason is the isolation. So there are some specific benefits with respect to security and isolation, which you can get by deploying your containers on VM rather than deploying it on direct bare metal. So especially on a software-defined storage like PowerFlex, which I'm going to cover in the next couple of slides, you get the isolation and then also the consolidation benefits of running multiple container stacks within VM on the same PowerFlex infrastructure. So as I mentioned, let's go through some of the key power positions or key values of what is PowerFlex, and then also what are the key differentiations with PowerFlex. So PowerFlex, Dell EMC PowerFlex is a software-defined storage. And again, the three key tenets for this software-defined storage are harnessing the software, embrace the change, and deliver predictability. Harnessing the software is through the performance and scalability benefits, including fluidity. And then also the embracing change is with respect to the different kind of deployment architecture you supported, and then also the kind of different consumption models and then the platform support PowerFlex provides. And then also you can be sure of the workload execution predictability here. And then also it provides you end-to-end automation and orchestration capabilities. So why, again, the PowerFlex software-defined storage, again, if you want to go a little bit detail on this. So this is a software-defined storage known for its performance, scale, and resiliency. I talked about performance, how it can provide you that kind of extreme performance. It is due to the unique architecture PowerFlex provides. So PowerFlex architecture, you have like 3 or 4 nodes who are working, who are actually contributing to the I/O. Again, in the PowerFlex architecture, every node of the cluster is contributing with your I/O operations. Again, every single drive on the node is also contributing to the I/O operations. So this is one of the primary reason why you get this kind of millions of IOPS at sub-millisecond latency for any of these kind of enterprise critical applications. So the aggregated resources with respect to nodes and also the drives which contribute to every I/O operation provides you massive performance and also scalability benefits. When I say scalability, again, PowerFlex can be used with a very small footprint. You can start small and then grow big as needed. Again, you can start with like as few as 4 nodes, and then you can scale up to thousands of nodes without any impact to your performance or any latency implications. So the other key thing which is very critical for database administrators is, especially for database deployments, is the resiliency. And PowerFlex provides that 6 nines of availability. Administrator or a DBA, you don't have to worry about the storage platform because the PowerFlex will automatically heal on its own, and then it will do the rebalancing with the existing nodes. Similarly, once a node is online, again, it knows the node is online, and then automatically the I/O operations are optimized, and then the storage rebalancing happens automatically in the background. So this is really a key benefit, especially for database administrators who are managing mission-critical applications like Oracle, SQL, and then also some NoSQL databases in financial and other industries, because they don't have to worry about the backend storage for the optimized performance. They can focus on their applications, and then also they can make sure that the day-to-day operations are running smoothly. With respect to PowerFlex, again, the other key benefit or the value add is the flexibility with respect to deployment architectures. So in PowerFlex, one of the key differentiation is the disaggregated or the 2-layered architecture. Here, you can have compute and storage resources managed independently, and then also you can scale them based on your need. And also PowerFlex supports if you need a hyper-converged architecture or a hyper-converged model wherein you can have all your compute, storage, and networking resources on the same nodes. And there are also a lot of customers and then use cases where they start with a hyper-converged environment like a 4-node or 6-node configuration, and then you can, based on your need, you can add your compute resources to the same infrastructure. So you have all this kind of flexibility with PowerFlex. which is very critical for, again, databases and database administrators. And then also I want to highlight the other key differentiation with PowerFlex. Whatever is the kind of application, whether it is like a mission critical databases or a throughput intensive analytic application or like a generic mixed workload or a virtualization or a virtual use cases or a cloud native or container based applications, including AI ML use cases, and then whatever be the orchestration, whether it is VMware hypervisor or OpenShift or even a bare metal configuration, you can deploy your applications without any performance implications. So PowerFlex supports whether it is bare metal, virtual machine through hypervisors like VMware or Hyper-V, and then also containers on top of bare metal if required. So it provides you this kind of complete flexibility wherein you can confidently deploy different kind of application based on the needs. And then also PowerFlex supports some of the key features which is very much required for databases, such as native replication and inline compression, and including a lot of quality of services and also secure snapshots and others. So let us go through a little bit more detail about some of the reference architectures and validations which has been done with PowerFlex and VMware, again, especially on containers for enterprise databases. And I'm going to cover both traditional databases such as Oracle and SQL, including some of the work done with respect to NoSQL or modern databases like Cassandra and MongoDB. So as I mentioned, PowerFlex is an ideal platform for databases as well as containers because of the flexibility which I mentioned. It provides a complete flexible platform, and then also PowerFlex has an orchestration tool which is kind of capable of doing your end-to-end automation, and then also it dramatically shortens your complete life cycle by managing your system end-to-end, including networking, compute, and storage resources. And then also the flexible design, and then also the flexible models, which I explained, like two-layered architecture and the hyper-converged configuration, helps a lot with respect to databases. And then again, especially for containers, you have the flexibility again, depending on your need. You can deploy containers on top of virtualization if required, on VMs, or also on bare metal if required for specific use cases. And then there are also specific use cases where you can deploy some traditional databases like Oracle, probably on bare metal if required on the same infrastructure. So this is one of the reference architecture and the validation I wanted to just highlight. Again, this is a SQL 2019 big data cluster, which was actually deployed with PowerFlex, and then also the Kubernetes containers were used with VMware hypervisor. As I mentioned, there are specific use cases, and then there are a lot of advantages of using containers with VMware hypervisor, wherein in this solution, we were able to easily isolate and then also make sure that there are some security aspects are taken care for those containers while deploying this on the VMs. So for this, again, this architecture, as you can see, this was started again, this was like a 4-node PowerFlex configuration, wherein the entire, the big data cluster configuration, whether it is the compute pool and the data pool, everything was configured as containers. And then again, the entire containers were running on VMs on top of VMware vSphere. And then the entire, again, the big data cluster consisted of various data sources like Spark and HDFS, which were used to pull in the data, and then actually the same data was processed through the SQL engine. So this solution again proved that we can have this kind of a container-based deployments for even like traditional databases like SQL, which is a more effective way of using all the resources. And then also it provides you all the benefits like, okay, the scale out benefits which you can provide. Again, in this kind of big data cluster deployments, there is always a challenge of data being like growing significantly on a daily basis. So this kind of environments will again help in scaling the environment, and then it's very easy to scale the environment in PowerFlex. As I mentioned, the scalability benefits, you can just add a node, and then automatically the PowerFlex will be doing all the rebalancing and whatever is required at the storage layer in the background. So it provides you the same kind of performance and the scalability benefit. And then again, the SQL Big Data Cluster, again, this is a detailed reference architecture. I'll provide you a link for this solution. Just wanted to highlight that the entire Big Data Cluster environment can be deployed as containers on top of VMs here. And similarly, we did a solution with Oracle, which is one more traditional large enterprise database. Oracle, again, it was done on multiple, operating systems and then multiple container platforms. And then also Oracle 12c and 19c, both were used as there are still a lot of customers using 12c, even though 19c has been released. Again, there is a lot of use cases, especially for Oracle, where the customers are looking for test dev and DevOps kind of environment. Again, in this solution validates that. Again, this was done with Kubernetes containers running on top of VMware. So the links are the URLs for this detailed solution. Again, whatever I shared there is very brief update on some of the key architecture concepts. But again, these are the links, are the URLs for these two solutions, which will provide you all the details, including sizing, how you deploy, and the reference architecture for these two solutions. One is the SQL 2019 Big Data Cluster on PowerFlex with Kubernetes and VMware, and the other one is the Oracle on Kubernetes with VMware running on PowerFlex. So as I mentioned, in addition to traditional databases, again, NoSQL databases like Cassandra or MongoDB, these are very predominant with containers. Again, PowerFlex as can provide, not only it can support any kind of virtualization or bare metal, and then also it provides support to bare metal configuration and containers. And then it also has all the support required for deployment of containers like CSA support. And then also the benefits which you can get with respect to scalability is really ideal for these kind of NoSQL databases. And then what you are seeing here are some of the solutions which we have validated for cloud native applications like Cassandra on top of PowerFlex with Kubernetes. So just to conclude, whatever is the kind of applications, whether it is traditional databases like SQL Server or Oracle, or whether it is like a modern NoSQL database like Cassandra, or an analytics application like Elasticstack or SAS, PowerFlex can provide you the most predictable and performance-driven outcome for your applications. As you can see, some of the in-house performance numbers here, the number you can get up to 10 or 11 million or more than that IOPS for any of your applications with kind of sub-millisecond latency. For an application like Oracle, you can get like 10 million IOPS with sub-millisecond latency. And then also for modern applications like Cassandra, you get up to like more than 300, 400K operations. And the key thing I wanted to highlight here is these are all performance numbers which you can expect or get from PowerFlex with sub-millisecond latency.
Hello and welcome to this short tech talk. My name is David Espejo. I'm based out in Colombia, South America. In this session, I will share some history around how the data persistency models have evolved in the Kubernetes design throughout the years. So let's get started. Well, first of all, the origin of this history was Kubernetes needed a way to handle the provisioning or consumption of storage, right? So this system, no matter if it was born inside Google or how it has evolved outside of Google, it has always needed a way to handle storage consumption. So the first notion of this was the static provisioning that is even not here in the presentation. That is step 0, static provisioning. So Kubernetes could only handle mount and unmount operation, but someone else will have to provision the storage for Kubernetes. So then it came dynamic provisioning, which is a way to connect the pod API. The pod is the basic execution unit in Kubernetes. It's like the VM, let's say, in a vSphere environment. So dynamic provisioning is a way to connect the pod object to a system that provides storage, right? So it's dynamic because it responds to a different logic than just a manual mount or unmount operation. So there are two ways to provide dynamic provisioning to Kubernetes. The first of all was internal or in-tree. So internal is the kind of volumes or storage that Kubernetes can create by itself. So Kubernetes was not born thinking on data persistency, because most of the applications designed to run on top of it are stateless or were stateless. So data persistency was not the priority, let's say. So the internal dynamic provisioning or in-tree storage services were pretty much limited in functions. And when Kubernetes was released to the world, was donated to the CNCF in 2015. The first option for storage providers was to write code and to ship and CNCF to communicate with the storage provider in order to merge that code into Kubernetes itself. So you can imagine how hard can be that to manage at scale, and that affected the agility of the release cycles of Kubernetes. So there was another way that is the external or out-of-tree dynamic provisioning, in which Kubernetes provides the pod a way to connect to an external or custom provisioner created by a specialized storage vendor. So that's great, but it's not complete because it provides just a limited set of options. And there's a question remaining out there, and it's how to translate the different storage requirements for my applications to this limited set of functions. So if you go to a virtualized data center, probably you will agree with me that all of the applications deployed there in the VMs, not all of them require the same in terms of storage. Some applications require low latency, extremely high performance. Some other types of applications are not latency sensitive but require more capacity or more reliability or durability, etc. So there is a diverse set of requirements, and just having the storage management inside Kubernetes, it's a limited way to achieve those requirements. So a little step ahead was the creation of the volume type called Flex Volume. Why Flex? Because it's let's say it's a plugin. It's a plugin to communicate the pod API. Again, the pod is the execution unit for Kubernetes, to communicate the pod API with external storage drivers. So that's great. The thing is that Flex Volume, it has to be installed in every single node of the Kubernetes cluster. And that implies that it's part of the execution environment or part of the execution scenario, let's say, or execution namespace, let's say, for Kubernetes. It's like installing a driver or a plugin in your ESXi node. It's great, but if that driver happens to have a compatibility problem with ESXi, it will take down your node. So it's not great to have the plugins there, at least in Kubernetes. And all of that just to have attached and detached operations. So it was a little step forward, but not enough. So that prompted the CNCF and Kubernetes community to develop an specification, a complete set of or a protocol to define data models for Kubernetes, and that is the CSI, Container Storage Interface. It's a way to create, let's say, cloud native storage, right? So what is the main idea behind CSI? Decoupling the storage management from Kubernetes, right? So there are many components in a Kubernetes cluster, but there is one that runs on every node in the cluster, which is the kubelet. The kubelet is, let's say, the agent that runs on any node. So the CSI is the massive undertaking of decoupling storage management from Kubernetes, but letting a bridge or a way for the kubelet to be able to find the volumes and mount the volumes, and that's it. But Kubernetes won't be responsible for create them, destroy them, manage them, not a single bit of that. So that is important, because when you combine that with dynamic provisioning, if I take a step backwards, let's say, dynamic provisioning requires the use of a concept in Kubernetes that is called storage class. Storage class, it's, let's say, like a storage policy or storage profile in vSphere. Let's say it's a way to specify these are the requirements or the features I need in this specific type of storage for this specific type of applications. You can have several storage classes, as you can have several storage policies or profiles in vSphere. So storage classes are a declarative way of defining requirements for storage. So if you combine that with CSI, you can have a very flexible and also scalable model of handling storage, because you can define in a flexible way your requirements, and also you can manage the storage in a logic separate from Kubernetes. So you will be able, for example, to upgrade the Kubernetes cluster without having to upgrade the storage components. So that is very important. So in a, let's say, graphical way, I found this diagram clear enough from the guys at the New Stack magazine. And, you know, in this diagram, the developers just require storage for the application, and that's it. You know, the application run in pods, and the developers request storage using a construct called PVC, persistent volume claim. It's a way to define the storage requirements. And in both approaches, dynamic storage will fulfill the requirement. The end result probably is the same. In the right-hand side, CSI, it's kind of a bit more complex, but you can see there that is decoupled. In the left-hand side, you will see a volume controller inside Kubernetes, right? So there is external code running inside Kubernetes. So that has this limited set of features that I talked previously. So when the developer performs the request, the API server, which is kind of the gateway, or let's say like a vCenter server, the API server will receive the request, and the volume controller in the in-tree approach will find if there is a volume already created with those requirements, and if that's the case, it will publish or it will assign that volume to that pod. Right? The kubelet, in both cases, the kubelet will perform the mount operation. In the CSI world, in the right-hand side, there is an external provisioner. This is provided by your storage vendor, right? So your storage solution for Kubernetes, be it in the public cloud or on-prem, should have a CSI compatible solution. It will provide an external provisioner, which happens to be another pod running in the cluster, probably in a different namespace, but running in the cluster. It will respond to the request, and Kubernetes or the kubelet just perform the mount operation, right? So all the logic, because this is a simple operation. This diagram is pretty much simple because it only mentions the mount operation. But the more mature drivers or CSI drivers these days provide not only mount or unmount, they can create the volume, mount the volume, resize the volume without affecting the applications, snapshot, restore the volume, unmount the volume, and destroy the volume. So all the life cycle of the external storage is managed by the CSI driver. So in this way, you can scale Kubernetes and keep the storage management separate from that. Right? So how can I know if my storage solution or my cloud provider has different features in the CSI driver? There's a public list in the Kubernetes documentation. You can just Google Kubernetes CSI drivers, and you will find here a list. This is just a snapshot of the list. You will find here a list of all the vendors or cloud providers, the current versions of their CSI drivers, and the features they provide. So it's important to check this when you're, researching platforms to run a Kubernetes environment. Right? So I hope that's clear. I appreciate so much your time and thank you for watching.
Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're going to talk about some troubleshooting tips and tricks to NSXT. So to start, what we have in the box for in the NSXT box that help us to troubleshooting when we have some problem or we're facing some issues with the solution. We have syslog that we can send logs to either login site or other log solution. We can have multiple syslog servers configured to NSX, so it works really well. Also have TraceFlow. That's a powerful tool where you can select like the source and the destination workloads, and check the path between those two workloads. Also topology map, that's something new in 3.0, where you can see like all their segments and T1s and T0s, that clusters that are connected, the Kubernetes cluster that are connected to NSX. Also, what are the namespaces, configure them, and the containers, the labels, and everything. Also, the ingress rules. Mirror, either logical span or ER span. They are really useful for troubleshooting. IPFix and VRNI, that's got better in the last version. And latency. So the latest part is really nice. It's really useful when you need to check if the communication between any transport nodes are working fine or not. So for each one of those, when you integrated login site with NSX, it has a content pack that brings all those nice charts to login site, and also these blue words here are called extracted fields, and they are the log parsing. So it helps login site to index all the unstructured data, information, an event, an error, or everything that happened in NSX or any other platform. The next one is TraceFlow. Here we have TraceFlow. So we're going to select a source workload that can be either a VM or a pod, and the destination workload that can be either a VM, a pod, or an IP address. In the case of an external IP address, you check the NSX communication up to the edge nodes. So it will check if everything from the workload up to the edge node is working fine. In our case, we're gonna select a container as our source workload. Here it's Delta Force app, and we're gonna test the communication to web A. After the test is done, we can check here all the components that participate in that communication. Here I have the pod, the segment, T0, T1s, and also we have the hypervisor that are hosting that pod or that workload. Something that's nice is that we can see here the IP address of that workload of the hypervisor, the management IP address, and also the hypervisor version where is NSX installed. The other feature that was added to NSX 3.0 was the topology mapping. So the topology map is something that's really helpful to understand the NSX topology and what's connected to what. So here you can see that we have our T0. We can download the routing table, the forwarding table, check what's the BGP neighbors, also the T1 configuration. When you have multiple segments connect to the same T1, we're gonna group them, and also can ungroup them to see what's connected there. Here we have a segment Delta Force that's being used for 4 pods. We can also check the labels that those pods are using, and we can export that to PDF, and also have a mini map here that is really useful to look to search something really quick. Topology map, it was something that people was asking a long time ago, and now it's happening in NSX. So I'm a really fan of that. Containers inventory, it helps a lot to figure out what we have in the Kubernetes cluster that are being used. That it helps a lot to cross-reference what you have in Kubernetes and also what you have in NSX, and it helps to create firewall rules and check what are the rules, the ingress rules created in NSX. So here you can check the containers and the clusters. In this case, we have 1 cluster working and 2 clusters that are not connected. And we can check that there's 3 nodes in each one in that cluster. We can look for a specific namespace like Delta Force, and we can check like the ingress rule. We can check what has been configured for load balance. In this case, we have a URI rule that's balancing /app and /web to our pods. And also we have here the SSL offload that has been configured. We can also check here the pods that are connected to that namespace, and also the service. In this case, we have 2 services, web and app, and also all the segments T1, T0 that communicate, that are being used for that Kubernetes cluster. Other thing that's available in NSX also is the port mirroring. We have 2 types of port mirroring in the simplified UI. We have the L3 span and also the logical span. The cool thing about L3 span is that we can mirror the whole segment. In this case, we're going to mirror a segment that's being used for a container, and we're going to send that traffic to an external IP address using GRE. In this case, I'm sending that traffic to my desktop computer that has external IP. Here I'm going to start Wireshark and do a little filtering here to get only the pod network. I'm going to generate here some traffic, 172.26, and after generate some traffic here, I can check all the communication in that network that's really useful for troubleshooting and to check if everything is fine or not, if why some application is not it's not communicating with another. So it's something really useful and really helps when you face a problem with connectivity. VRNI, in the last version of VRNI 5.2, we have a new dashboard, an SXT dashboard. It's providing a lot of useful info for NSXT. So here in the right side, we have the topology, the NSXT topology, with all the controllers, managers, and also the nodes, the transport nodes. And when you click in a transport node, we can check the traffic that's going, that's ingress traffic, egress traffic, the latence between that transport node and other transport nodes. Also the traffic that's being received, the traffic that's being dropped, and also the usage, the disk usage, CPU usage, and memory usage. And so it improved a lot. Something that is really cool about this dashboard also is we can check here how many VMs are hosted in that host. What's the transport zone that is being used, the IP address, the management IP address, and also if everything is fine, like what's the connectivity status to the management with NSX or not. Also, NSX, the new version, I think it started in 5.1, and also in 5.2 we'll have the dark mode. Dark mode sometimes is helpful for people that likes dark screen the whole day. So in the Kubernetes integration, these dark modes got really cool because there's a diagram here of service that looks really nice. So here you can check like the namespace, the service of like that of the container integrated, the Kubernetes integrated VRNI solution, and here's the diagram of the service. So here you can check like all the pods that are configured to that service, and also we can check here the NSX that's integrated to that Kubernetes cluster. Also, if you have here like a connection to a physical device, and also like the firewall rules, and here the master nodes. So this diagram here really help us to check in a graphical way what's happening in the Kubernetes cluster. That's all I have. Thank you very much for watching, and see you next time.
Hi everyone, my name is Itzik Kai. I'm Vice President of Technology here at Dell EMC. And with me, I have Paul Mitchell, who is our Field CTO for Data Protection Solution. And today we're going to talk about accelerating adoption for VMworld Tanzu, enterprise storage, and data protection options for Kubernetes workloads. There's probably a single application that ran on these operating system. Then came VMworld with a radical different thinking and say, you know what, why don't we consolidate all of these applications that don't generate a lot of CPU and memory consumption and run a very thin layer of an hypervisor on the top of that bare metal server. And then each VM will consume its own operating system and memory and CPU cycles, but together we can actually stage a lot of these bare metal servers that don't do a lot. And that used to resonate quite for a very long time, including today. But then in 2015 came a small startup called Docker and said that maybe there is even more efficient way of running applications on the top of the bare metal servers, but basically running a single operating system on that bare metal server. But instead of running an hypervisor on the top of it, what they did is basically fork, if you will, the kernel of that operating system, and each one of that fork ran its own application separately. So each and every one of these applications is not aware of the other one. And by doing so, you can actually save a lot of this cost on these operating system that runs on the bare metal server. And that is an absolutely valid way of running containers today. But there is also a new emerging way of running containers on the top of the bare metal servers. And that's the way that VMware chose to do, which basically still run an hypervisor, a very thin layer of an hypervisor on the top of the bare metal server. But on that hypervisor run the Docker runtime. And by doing so, you can basically enjoy both of the worlds. You can still isolate each one of the container runtime from the other containers that are running on the bare metal server. But things like high availability, vMotion, VRS, all of these features that you used to know and love from the VMworld still exist. So you benefit from them immediately while running them on the top of the hypervisor with the Docker runtime. And if I then compare and contrast this to the storage management world, still today, people are probably managing the storage array from the user interface. So in this example, you see our PowerFlex, our software-defined storage UI. So to the left, you can see how to provision volumes, and to the right, you can see a way how to monitor the storage array. And automation, if you will, was probably script via the storage array CLI command, the way to automate and accelerate, for example, volume provisioning. That was the best way of automating the storage array using native storage tools. The thing is that everything is different today. People expect to treat your storage just as a line of code, just like everything else that evolves around writing and development and writing application that will run inside your servers. So storage is just another element, if you will, that is important, but it's as important as any other line of code for the developers that are basically developing the software on the storage and the compute and everything else. So for them, they just want to, with a single command, do everything that evolves around storage management without touching the storage user interface. And into that world of the Docker runtime came many, many orchestrators that did exactly that. And the leading orchestrator that basically has won the war big time is the Kubernetes orchestrator. And there are many reasons why Kubernetes succeeded, and it's now become the de facto orchestrator that is running on the top of the Docker runtime. Some of the reasons are full automation around everything. Starts with self-healing. So if a container fails, Kubernetes will know how to spin up a new container that will mimic the failed container workload. It's very easy to upgrade the entire stack where you go with Kubernetes. It's very easy to scale your workloads. So think about database that comes, for example, Christmas. It's very easy for you to your retail shop to just spin up another database that will automatically load balance itself within the rest of the databases in your backend and will fulfill your user request just for that time. And just like you can do spin up and scale up, you can also scale down if the workload demands are shifting, which is something, again, that is very, very new to the way of writing application these days. On the storage management, which is our focus in this session, is really everything around storage orchestration. It is very, very easy to provide storage management capabilities directly from within Kubernetes. So let's actually talk about those options. At the very high level, the thing that you are looking for in a storage array when you work with Kubernetes is a plugin called CSI plugin, which stands for Container Storage Interface. The Container Storage Interface really provides you the ability to extend your existing storage infrastructure into the Kubernetes management itself, and by doing so, provide microservices help and assistance to your running containers. Now let's go a little bit deeper into the architecture of the CSI plugin itself. How does it work? In a nutshell, if you're using a block storage, for example, a volume in the language of Kubernetes will be a persistent volume, which basically means that when you're a Kubernetes administrator, you log into the Kubernetes interface and you claim actually a persistent volume from within Kubernetes, which stands for PVC, persistent volume claim. And in advance, if your storage array speak, Kubernetes will answer with a persistent volume that will be provisioned for that container that you just spin up in the system. However, this is just the basic offering. Modern storage arrays such as PowerFlex or PowerStore or PowerMax in our portfolio can also give you the ability to provide unique capabilities that are coming outside of just the provisioning operations. For example, in the case of PowerMax and PowerStore, you can also designate quality of service for your running containers. So you will know that none of these containers that will be maybe spin up will manipulate the entire storage resources for that specific container workload. Now, let's see how it's actually all tied into VMware, because up until now, we only talk about Kubernetes itself. VMware in 2020 came up with vSphere with Kubernetes, which can be part of the VMware Cloud Foundation, but it can also be consumed in other fashions. VMware basically invested a lot in adopting Kubernetes and attaching it to the very core of the vCenter interface by both the management element and also the ES6i kernel itself, providing you really an holistic approach to manage Kubernetes workloads directly from within vCenter. So if you're a vCenter administrator, the familiarity of the UI will be immediately on the spot. If you're a Kubernetes administrator, you can still continue using the kubectl CLI, basically creating container pods, creating and storing them as you go. From a storage management, which is what we are discussing now, really there are two options that your storage array can interface into vSphere with Kubernetes. The more traditional way is to use VMFS data stores. Pretty much every storage array under the sun today provides VMFS capabilities, nothing new here. However, the more modern way, if you will, the first-class citizens option is really to provide volumes and storage volume to the VMworld with Kubernetes via vVols, VMware Virtual Volumes. We're going to talk about the benefits in a second, but that's something to bear in mind that both of these options are available to you as a customer. And the third thing that I want you to take out of this specific slide is that in the case of running vSphere with Tanzu Kubernetes Grid, we, the storage vendor, do not provide a CSI plugin for you, just like we will in a vanilla Kubernetes distribution. Because the CSI plugin in that case is provided for you by VMware. We interface into VMware Tanzu Kubernetes Grid via vVols or VMFS, as we mentioned before, talking into the VASA element that acts as a bridge, as a communicator, if you will, between the storage world domain to the vSphere and the Kubernetes domain. Now let's talk about why should you choose VMFS or maybe another approach. So if you go with VMFS, which as we said, pretty much every storage supports today, you probably want to stick with statistic provisioning. And in a second, we're going to talk about what it is, but something to bear in mind that when a container is being brought up to the world, the data of that container itself runs on VMDK file, just like any other VM. So you can look at the VMDK file, take a snapshot of it, move it around, nothing new. Those are, again, the benefits that we discussed in advance. Why should you choose to go with, for example, VMware with the vSphere hypervisor beneath? Because it's still using the VMDKs as before. While using VMDKs, you have two options that you can provision provision your running containers: static provisioning and a dynamic provisioning. A static provisioning, which is really a manual provision, basically means that the vSphere administrator or the storage administrator, if you will, needs to prepare in advance the VMDK volume, present it to that running container, and then when the container is being brought up, it will use that specific VMFS with that specific VMDK. If you delete a container, for example, the VMDK file will not be deleted automatically. Or maybe should you decide that you need more capacity, you need, again, in advance to discuss these storage needs with your storage administrator, prepare these storage volumes, format them as VMFS, and then finally present them as VMDK file. So you probably already start to say to yourself that maybe that doesn't really scale, and it requires a lot of manual intervening, and you're absolutely right. However, it is an option for storage arrays that do not support vVols, just to go with VMFS. For storage arrays that do support vVols, as we said, such as PowerMax, PowerStore, and PowerFlex, there is a much, much better way to do it, which is the dynamic provisioning, which is done with vVols. Here, the way to think about it is like a menu. Imagine yourself going to your favorite fast food restaurant. You're probably going to see a catalog of couple of your items that you can order, and the same apply here. You probably want to designate a couple of different service level agreements. In the language of Kubernetes, those are known as storage class. And storage class can really mean many things, but in the context of storage, it is very likely to mean quality of service, for example. Maybe you want to designate the size of the volume with specific IOPS that are tied to that specific storage class. So when a Kubernetes admin will now go ahead and provision, for example, their database application, the only thing that needs to be pre-agreed in advance is the storage class that you want to provision, how much performance maybe is associated with that specific container. And then, I'm going to show it in a demo in a second, once the vSphere administrator logging into vCenter with the Kubernetes UI, it will automatically provision that vVols from within the underlying storage array. We're going to use PowerStore in our example, carve up that volume, attach the quality of service to this vVol or vVols if the running container contains more than one volume. And by the time that the container will be shut down, you have options such as keep those volumes to stay up and running, or maybe delete them if you will. And all of those things are done automatically for you. The only thing you need to prepare in advance is this service catalog. What's the SLA that you want to designate in your organization? Most of the customers that I'm talking to are sticking with those three. They don't want to make it overly complicated because then again, there are too many reasons to consider, and they stick with gold, silver, and bronze, which really means different quality of service that can be applied to the running containers. Now let's take a look on how it can actually be applicable to real world cases with real storage arrays under our portfolio. To the left, you can see our PowerFlex storage array, which is our software-defined product. Let's assume, just for the sake of this example, that I assign the gold service level for that storage array. Again, gold can mean many things, but for the sake of the example, let's assume that I actually want to provide it the best performance possible. To the right, you see another service class, storage class that I created, and I assign it a silver storage class. And in this case, I'm using the PowerStore storage array, which is our newly announced mid-range storage array. In that case. And now I'm only selecting the gold service class, which if you recall, we already pre-assigned and pre-agreed in our organization that we're going to select or make available as an option. And if I'm now choosing gold, Kubernetes and VMworld will be smart enough to interface via the VASA provider to the storage array that exposes its capabilities and the one that we agreed upon in advance that has the gold service automatically. So nothing needs to be done here manually. So let's see how it actually looks using the PowerStore UI. So let's see a demo, how it all looks and how it's all tied together with the vVol interface with VMware and Zoo Kubernetes Grid. Let's see a demo. Right, so let's see how it all looks together with Dell EMC PowerStore and VMworld Tanzu Kubernetes Grid. What we see here is a Tanzu Kubernetes Grid deployment cluster that we deployed in advance, which now can be shown here as the WCP cluster, the PowerStore storage for that particular workload. And if you recall, what we now need to do is to specify the storage policy, storage class in the language of Kubernetes that is going to be exposed via PowerStore. We're going to use vVols for the Kubernetes running workloads. PowerStore is a very advanced storage array, and one of the capabilities that it surfaces is quality of service priorities, if you recall that we discussed earlier. So we are just going to create a vVol rule known as high QS policy, which means that if the Kubernetes administrator will go ahead and select I for its storage class, it will automatically know to apply the high quality of service option from within PowerStore. And of course, you can use the low, medium workload, depends on what exactly you want to run within your Kubernetes workloads. So now that we specify the VM storage policy, the next step for us is to go ahead and actually use PowerStore for that particular workload. So we're going to go back to the vSphere UI, to the workload management, create a new namespace. Just create the namespace here. As you can see, it has its own unique UI, which is part of the vSphere. And now we're going to direct that namespace to use the PowerStore vVol with the IQS policy that we just created a step before. When this is done, we now log in into the Kubernetes kubectl command, which is the familiar tool for the Kubernetes administrator. They are very unlikely to use the vSphere UI. They're using the kubectl. But as we said, each and every one of the parties has its own CLI or interface that they are going to work with. And now what we're going to do is to actually run the VMworld CSI that we told and explained that is being used here. In that case, well, because we're using vSphere with Kubernetes and Kubernetes Grid, it is not using the storage CSI, but rather the vSphere CSI. And we're going to show it and tell it to use the PowerStore storage class that we designated before. The next step is really to bring up an application from that particular, if you're not familiar with Yugabyte, it's a next class database that, unlike traditional databases, can truly scale out. You can literally, within a click of a button, tell it to create new instances of that database, and it will automatically spread the load between all the available containers. That's the PowerStore UI. What's unique about it that even the UI itself has a very tight integration within vSphere vVols that, as we mentioned, is what we are using in the case of VMworld TKG. And what you are now looking at is every time that we bring up a container, that container will use a couple of vVols. There will be the config vVol, the data vVol, the sock file of that running vVol-based VM. And it will actually run and show you the name of the running container workload that we just specified. So in that case, we call it Tomer TKG01. So you can actually see the container name is actually the prefix for all the running vVols in the system itself. Lastly, we can also see that we are running a scale-up architecture we mentioned before, which is what we see here. So we wanted to scale the Yugabyte database deployment. So literally within a click of a button, it will create more containers and of course attach new vVols to them. And which now you can see from within the storage array of PowerStore here. So if we now go to the storage container to the vVol tab, we will see that more vVols are now associated with that running a workload because we just decided to scale it up. And look at how easy it is to scale out the container workload, and how easy it is to also scale the vVol implementation. We did a lot of optimization within PowerStore itself to be able to really provision many vVols at one go, because we recognize that's a very known scenario that you want to burst your running containers and you want to do it in a very quickly manner. And so that was the demo about how to use PowerStore vVol with VMworld Tanzu Kubernetes Grid. With that, I want to introduce Paul Mitchell, who is our field CTO for data protection solution, who is going to talk to you around the options to run data protection for Kubernetes workloads. Paul, the ball is over to you.
Thank you, Itzik. Appreciate it. That was a great insight in how obviously we can actually interact with storage natively with Kubernetes. I'm actually going to spend the rest of the time today's presentation talking about data protection. This is normally quite a strange conversation to have when it comes to Kubernetes. As customers move into this agile workload, there's a huge push in the industry to move things into an agility standpoint, moving platforms very, very quickly. And one of the things that we find in the conversations that we have is ultimately that people are ready to push applications where the traditional IT operations teams are not ready to do so. So if you look at this interaction that I'm sharing right now, is that obviously the developers willing to push the application very, very, very quickly into the industry, but obviously the IT guy has operation considerations when it comes to compliance, backup, and disaster recovery when it starts to move into a different agile-based environment. I'm going to spend the rest of the time talking about PowerProtect. PowerProtect is Dell EMC's or Dell Technologies data protection strategy application that protects virtual machines natively, as you would expect, enterprise applications, as well as container workloads that Itzik has just basically covered for us. We're actually working in conjunction with PowerProtect with Velero. Velero is obviously a VMware-based technology that provides integration into Kubernetes infrastructure using the kubectl API. PowerProtect allows us to protect everything at the namespace layer and provides functionality that we can protect namespaces. We can actually restore namespaces to the same cluster, to a new namespace or an alternative cluster. And we can also include or exclude the PVCs or the basically persistent volume claims that Itzik covered earlier on today. We provide the ability to take not only advantage of the CSI interface, but also to talk about some of the functionality that we bring to the table when it comes to integrating further with VMware. PowerProtect allows us to not only maintain and give you a choice of how you wish to protect the data when you're running in container-based workloads, but also the agility to be able to provide different interfaces, because that's one of the things that we're seeing in the industry is obviously people want a choice, and we'll cover that in the next couple of slides. Obviously, really around governance and compliancy, when we're talking about workloads, we want to make sure that we can recover these workloads. And what we've done with PowerProtect is predominantly taking advantage of, as I said, the Velero integration, and we'll cover that further, but also leading into Dell Technologies' deduplication data protection strategy as well. So now we can provide best integration and best of breed solutions when it comes to Kubernetes and data protection workloads from a consistent messaging and a consistent tool set. I mentioned a choice. Well, choice ultimately is if, again, do you want to use kubectl? Do you want to use a native GUI-based interface? Or do you want to leverage things like basically the REST API? We're giving you a choice of where you wish to do your level of management as you need. It gives you the ability for orchestration to be able to provide it through the interface. And we can do some nice things around there, looking at basically audit trails and compliancy and meeting business requirements, but also the ability for effectively the Kubernetes administrator to still be able to do backup and recovery, but doing that natively within the kubectl API. We can take advantage of labels, and labels obviously beginning to label the namespaces. Just think about them like you do tags or key value pairs that I can associate with the namespace so that I can do dynamic agile protection of those new namespaces and pods and containers as they come online. Simply by just labeling those using the CLI within PowerProtect, I can simply discover those very quickly and agile, put them into a policy to be able to provide an ongoing protection strategy around that. As I mentioned, with everything that we're doing in the organization, REST is very first and forefront into the technology choice. So we're giving customers a choice of where they want to play into this to provide an enterprise class solution for their data protection needs. If you look at really Kubernetes as a platform, Kubernetes is really orchestration of containers, and Itzik again did a great job of talking about where that sits. But where we feel here is that obviously, protecting just a snapshot or just effectively the PVCs that we talked about is only part of the solution. And with PowerProtect, we're actually able to obviously protect not only the traditional PVCs and obviously that using the CSI framework, so again, providing the container storage interface capability to provide a snapshot mechanism, but also to be able to protect things that you wouldn't anticipate part of that. So again, as you rotate through your agile environments, things will change like for example, deployments and, for example, secrets. And obviously just replica sets and things will change. And with the beauty of actually integrating both Velero into PowerProtect, we can take advantage of protecting both of those. So we're actually giving you the ability to do a very flexible schema to be able to protect the data, but also to be able to restore it with its current control sets into any environment you need. We actually deploy 2 namespaces within the Kubernetes cluster. This is part of the PowerProtect Data Manager. One of them I already mentioned is the Velero. And the other piece of this is the actually PowerProtect namespace that actually provides a controller for actually orchestration and then data movers. One of the things that I mentioned earlier is obviously we're leveraging Dell Technologies' first and foremost enterprise-class data protection strategy in the sense that we're actually providing deduplication and compression at a source layer before we move anything into protection storage. And this is all part of this orchestration that we provide with the PowerProtect engine. If I look at the integration point, we actually work with PowerProtect predominantly with any CSI implementation that has been validated. CSI as a standard is still being ratified and is very early in some distributions, but effectively PowerProtect in conjunction with Velero using the CSI framework allows us to be able to protect those orchestrated workloads, again, using that technology. I want to talk a little bit further about where we've gone to the next level with VMware, and this is the reason why you guys are attending today's session, and we really appreciate your participation today. But from an integration standpoint, was specifically around VMware Tanzu, is that we've added some feature functionality which is different to everything else. So again, Isaac mentioned already how effectively we're using the VMware CSI framework for integration with storage. We're still using that, but one of the nice things that actually came into play, and 2 things I want to talk about from this, is that we do have our ability to manage this again from the cloud native control plane inside VMware, but also we give you the ability to use a new feature that was implemented in 6.7 update 3, which is actually called first class disk. First class disk is a functionality to be able to take a snapshot of that disk without being attached to an instance or a running machine. And that was a great feature functionality that was asked for many years. And we're taking advantage of that with effectively what we're doing in conjunction with Tanzu. Secondly to that, we're actually using the same data mover technology within the same namespaces, but this time we're actually using deduplication in conjunction with change block tracking. Change block tracking is a very capability that's been alongside VMware for the longest time. And here at Dell Technologies, we've been using that for efficient data protection backup strategies of virtual machines. But now we're bringing the same capability of that into effectively protecting containers. So now that we're only sending the unique data changes post deduplication and compression to the protection storage. Just to give an example of that, by looking at a couple of screenshots here within PowerProtect, if you look at the left-hand side, you can see that part of the first policy from this particular snapshot, the first data change rate that I sent was 108 megabytes. But subsequently, the second backup as it continued was only sending 76 kilobytes worth of data change. Again, these are the things that's happening with the integration, again, between Velero and obviously PowerProtect and obviously the integration inside VMware where we can take advantage of change block tracking. You can see this is a huge efficient capability that provides that with a full orchestration engine, providing protection of your Kubernetes solution end to end. I wanted to end today just to kind of wrap up really where I talked about from a data protection standpoint. Again, one of the things that we want to leave you with from a messaging standpoint is that with Dell EMC or Dell Technologies PowerProtect solution, we're able to give you an enterprise class solution to provide you a whole private cloud infrastructure, whether that be virtual machines, enterprise applications, and of course, containers that we've discussed today. We're obviously best of breed, obviously better together, working in conjunction with VMware to provide the best solution, taking advantage of feature functionality where we possibly can. And again, as I said, we've already mentioned using it in conjunction with Velero and in conjunction now using CSI integration to be able to provide best of breed solution. Thanks for joining today. We appreciate your participation and I hope you gained something from it today. Thank you, guys.
Thank you.
Hello, I'm Patrick Kramer, a staff cloud solution architect on the VMware Cloud AWS team here at VMware, and I'm here to talk to you about skills modernization for the virtual infrastructure admin and modernizing your skills using a VMware open source product called VEBA, VMware Event Broker Appliance. A little bit about me. I am a pre-sales SE now. Started at VMware in 2014. I've been working with VMware products since 2006, the 3.0 days. I've been primarily a sysadmin for most of my life, very limited programming background. And again, I'm a solution architect now selling VMware Cloud and AWS. Why would you want to modernize your skills? Obsolescence, right? We've all worked with floppies, at least those of us who've been around as long as I have in the industry. And I have spent many, many hours of my life staring at this Norton Ghost screen, cloning drives for servers and desktops. But those skills aren't in demand today, right? That doesn't help. So you have to modernize your skills. You have to keep with the times to keep yourself relevant and employable. So since 2006, I was doing all system administration. It was all system administration all the time. Virtual machines, your classic 3-tier apps, and started off doing physicals, and then virtualization came in, which really virtualization was the same work as a physical, but it was just an easier way to do it, right? Virtualization came with the ability to clone VMs. You couldn't do that easily with a physical, except with Ghost, but it was a lot faster in the virtual world. Kind of the same job. And my programming skill really was all scripts. So I went and looked at one of my old directories preparing for this presentation and found that I had amassed 440 Power CLI scripts, all of maybe 10 or 20 lines each. And that's what I would do. I'd go out to the internet and I would find a script that did something close to what I wanted and hack around and get the Power CLI to do what I want, with just little chunks and snippets of Power CLI code to do what I wanted. So we'll talk about 2013, VMware launched NSX, and just like when you were doing virtualization instead of physicals, this was networking. It's the same networking that we already knew. It was just a slightly different way to do it. And now we're in 2020, and we have all of these developer words. There's Kubernetes and Docker and microservices and containers, and what makes it difficult for people who come out of a system administration background is we're not learning how to do things in a different way like we were with virtualization, like we were with NSX. It's a whole new profession, and that's why it's so tough, and that's why it's so hard to get started. If you take a look, this is from CNCF, the Cloud Native Landscape. Like, this is a lot to understand when this isn't really your profession, when you're coming into this not really knowing even the basics. It's really overwhelming. So the question is where to start. So I started, and I'm proposing to you that maybe you can start too, with the VMware Event Broker appliance. I am not good at learning things just to learn them. I need a project. And the VBA project is event-driven automation for vSphere. It's an open source project. It uses Kubernetes, which I don't really know, but I'm gaining skill in it. But I'm learning Kubernetes in the context of something that I do understand really well, which is Virtual Center. So if you look at vCenter automation today, when anything happens in Virtual Center, you have an HA event or a data store gets full. You have the same 3 alarm actions that you've had since like the beginning of time. You can send an email, you can send a trap, or you can run a command. It hasn't really changed since vSphere like 3, right? And it's limiting. You can just do those 3 things. And what VBA does is it actually reads vCenter events and can react to them. And you can write code in arbitrary programming languages. And there's a whole set of functions that are built in to do different things. A lot more than just send an email, right? Run a script, send an SNMP trap. For example, out of the box, one of the functions built into VBA is maintenance mode alarms. So how many times have you went to update a host, pop it into maintenance mode, go to reboot it, and you get a bunch of emails saying the host is down? Well, of course the host is down. You rebooted it. So this maintenance mode alarm function, when you put a host into maintenance mode, it disables alarm actions. And when you pop hosts out of maintenance mode, it enables alarm actions. So just a very simple reaction to an event that happens in Virtual Center, but it makes your life easier. This other one out of the box that was contributed by the community This is an HA event notification. So when there's an HA event, your host goes down and virtual machines are booted on a different host. You get an email that tells you, hey, this is when the virtual machines were restarted. Here's a list, and here's a date. So that's just a couple examples of functions that are there out of the box. It can do a lot more, but those are examples of what's there. So how did I get into this in the first place? Well, I needed to send notifications out of VMware Cloud and AWS, and because of security permissions and the way VMC operates, it's not possible to get into that section of vCenter. And one of the product managers told me, hey, there's this new VBA open source project that might be able to help. So I'm like, okay, I'll take a look at it. And first it was, hey, download an OVA, which, okay, I can do that. I've done that a lot of times. And then I'm reading what to do. And step one is clone the repo. Like, what does that mean? I don't know Git. I don't know any of this stuff. And then it's talking about stack.yml. I didn't even know what YML was. I now know it's called YAML. And then there's JSON. I'd heard of JSON, but I'd never used it. So it's using foreign terminology. I didn't really know what to do. So I thought, okay, I'll look at this YAML file. So it's just a config file. So this isn't too confusing, just a text config. And then I read, oh, you need Docker to be able to deploy this. And I thought, okay, I'm just going to log on to this VBA appliance and I'll look around and see what I can find. Well, all I found was a bunch of stuff called Containerd and Cube. And I'm thinking, where's Apache? Where's Nginx? Where's like MySQL? Where's the stuff that I know and understand? Well, it's not there because it's containerized. And so I sent back to product management. I'm like, yeah, Viva's a developer's tool. I can't use this. And the next day, William Lamb, who I'm sure you all know from all of his community work, he's like, yeah, it's actually targeted at virtual infrastructure admins. And William spent about an hour and convinced me, this really is in your skill set and you should give it a shot. So I said, okay, I'm going to give it a shot and I'm going to blog about it because I learn better when I go into it with the intent of not only learning it, but I'm going to teach it to somebody. So I started off and I deployed the appliance and I blogged about it. And it brought me into this open source world where all of these really hardcore developers are working on this product, and then there's me. So you want to talk about feeling like an imposter out of the gate? Take a look at this. So this is a screenshot of various people on the project. This is their GitHub. And every time you see green, that's a day that they contributed code. And the darker the green, the more code they contributed on that particular day. So, 374, 258, 413 contributions in the last year. And there's me, right? Nothing. But what I wasn't prepared for is just how helpful they were. Every single person on this list has helped me. They all want the project to be successful. People who contribute to open source projects, they want them to be successful. They want to help. They've helped me in Slack. They've helped other customers in the public Slack channel that we have for this project. And it really is a lot more welcoming than I think some of the initial fears that I had are, right? And I think a lot of people are nervous. And when you start to learn just a little tiny bit, using the right tools, don't list off the process, use kubectl commands. And I started to learn, okay, containers run code, pods are a group of containers, and they're organized into namespaces. And suddenly things start to make a little bit more sense. And pods have logs, so I can actually tail a log file the way that I'm used to doing on a Linux system. That all works. So really, 2 days after I started kicking around with this stuff, I found a typo, one typo in a README file. And I was able to fix it with a little bit of help from the people in that Slack channel. So I fixed it, and I committed a change back to the open source repository, and there we go. A couple days after I started, I was able to contribute to an open source project. And, it was just one character typo, but I was able to do it. So then I did some more, and you can see, well, I've amassed, not too bad for a non-programmer. I've contributed 34 times in the last year, and I've been able to put code into an open source repository. And the blog series grew. So I blogged on how to deploy code, and I blogged on how to get a function into the VBA, and I wrote about how I got my laptop ready to deploy code, and a bunch of stuff on Git commands. And over time, over the past 8 or 9 months, I went from writing documentation, and I updated some more documentation, and then I contributed some Power CLI. And then I did a little more documentation. So I've kind of jumped around and jumped into areas of the program that made sense to me and were easier for me to understand. Maybe the biggest thing that I did right here is it's a checkbox. It's just a simple checkbox, and it auto starts SSH when the appliance comes up. But I never could have dreamed of being able to edit something on an OVA deployment screen and actually have that impact the installation of an open source product without getting started fixing a typo in December of 2019. And if you really look at what's behind the checkbox, it's not that much, and it's something that most of us who've spent any time in Linux will understand, right? Right at the top, it's just a little bit of shell scripting. And in the middle, it's just reading a property. Now, do I know off the top of my head exactly what all those commands do? Not really. I did the exact same thing that I did with all my Power CLI. I stole it because it was already done on another property. So I just pasted that in. And the bottom too, it's just a copy and paste of properties that were already there, and it's just simple markup. So it really wasn't that complex once I got under the hood, and I was able to use existing experience and apply it to a new thing. So if I've inspired you, maybe I've piqued your interest, come check out VBA, and if not, think about finding an open source project that interests you, and go ahead and get out there and start helping. If you want to check out VBA, VMware Event Broker IO, the website, the fling's there. You can check out my blog post on it and learn a little bit about how to contribute and how to use VBA. And there's a public Slack channel too if you want to talk to the development team. All right, thank you.
Hi, my name is Sachin Bharadwaj, and I'm going to present you a session on microsegmentation. Microsegmentation is basically a buzzy word which you might have seen or heard from various people from the networking background guys, or maybe the compute. So it is something which has been trending from a long time, and it's also a great thing to use it in the modern infrastructure. So basically, what is microsegmentation? So microsegmentation is just a zero trust model which you are building it on your infrastructure, basically on the NSX platform. So it's something like a VM to VM communication where you have the capability to communicate a VM to a specific VM. It is without leveraging any specific traffic or anything else. So this is a common thing. Like if you're talking about in NSX environment, microsegmentation is allow you to push those traffic or segmentations where you have zero trust models, and which hereby privileging the putting down all the protection at every level, whether it's a virtual card, VM NIC, or anything else like a transport node that prepares from the NSX generation with the help of NSX preparations, that we need to say that. So how we are using this microsegmentation in today's world. So let's talk about the traditional environment which we have earlier, where we have the perimeter firewalls, which is as could we say the parameter gateway, which is at the topmost level of every organization or every infrastructure. So perimeter gateway is just used to protect you from at the topmost level. So I'm not saying anything wrong with perimeter firewall. It is definitely a good things to have at the topmost level to procure you or to secure you from threat which is coming into your environment. So that's pretty good. So, but what about the things which is there under the perimeter firewall? Let's say about the workload, or could be a virtual instance, or could be a container, or could be anything which is there inside the perimeter firewall. So that parameter firewall is not protecting all those things inside it. So that's something maybe a question of concern which we have to take it out. Let's say what could be the reason why we required micro-segmentation, or could be something which we required to protect down to that, because we already have the parameter firewall at the top and layer. Why we require something the down layer, or could be at the VM level or something else. So let me give you some case studies, or could be some examples why we required. Let's say your end user is using an application or accessing an email from your Outlook, and he got an email which is a phishing email which state anything about a Trojan virus or anything else which may hit you in your environment, and that may attack your environment, and possibly it could be something which may harm your environment and can take out your any data which is more secure with an environment. You don't want to take it out from the network outside your perimeter firewall. Second example could be an end user who is using a USB drive to extract any data or taking out anything from the network, or maybe installing any software that USB might be having an infected virus. Could be a Trojan horse. That's common in the network environment. So that may affect the environment, or that may attack it. Attackers are quite aggressive to do all those things, to hack your environment and do whatever they want. So to protect all of them, we required micro-segmentations to be enabled with the environment, so that our instances or our infrastructure down to the parameter firewall should be protected as well as. So in this presentation, I'll let you know about, I'll state about the challenges which we have in a traditional data center, which I have already elaborated to you. Describe NSXT microsegmentation, how it works, recognize microsegmentation use cases, and identify benefits of microsegmentations in NSXT environment. So let's get started again. See, so as I said, then traditional data center security challenges are quite high. So traditional security are more emphasis at the environment level rather than specific application level. So traditional environment is something which more emphasis at the parameter level, at the firewall, which is at the topmost, at the gateway side. So they are not much concerned about the application level security. Doesn't prevent from lateral between workload and the tiers. So that states the same thing. Let's suppose you have protected your parameter firewall at the topmost level, just like a fence. You have protected your house. And what else? What if somebody jumps from your firewall, from your fences, and go inside your house and take out whatever they want? So that is something which has not been prevented from the traditional data center parameter firewalls, or you can say any firewall which has been physically allocated. So there are more challenges on low priority target at first. Low priority targets could be anything about the VM, or could be any bare metal server, or anything which is there under the parameter firewall could be being the first priority to get it attacked by the attackers. So once you have the data center hijacked, or somebody hijacked your data center and entered your perimeter firewall inside it, they can freely go inside the data center and do whatever they want. They can take out critical data or anything else. So that it's really, it's a challenges which we have in the traditional data center. So how can we overcome with that challenges? So to overcome the challenges, we have certain things which required to be there. It should be having a zero trust at most granular level. What do you mean by zero trust? Basically, is zero trust is something like if you have an environment, if you have an application which is being set up, like two application which is being set up into the environment, and say that application, it's having its own boundaries or something which specify like this set of application required to connect to different application which specifically require a set of protocol. Let's say I have a set of application like web application, and I have another web application to get interacted with them. So the protocol which is reused mostly is HTTPS. So why not to do one thing? Why not to enable HTTPS traffic from one source to destination and drop all the packets which is not too required. So basically, it's something like we are giving zero trust or relationship, or could be a trust between two VMs, which definitely allows only single type of protocol and drop rather the other things. So this is one of the topmost things. It may be the application. You can define the application, whatever the application you have, and you can define the boundaries of that. Let's say you have an application or database application, and you want to flow only the database like SQL servers. You just enable the protocol. We have a set of around 400 type of protocols into the distributed firewall, which we are going to talk about in next slide, where you can enable those ports or channels into the security profiles of that VMs, and that specific protocol, that specific port will only connect with the destination. Rest all port and rest all traffic will get dropped out. What happens with that? It will minimize your traffic over the network. There will no congestion at all in your network, and that will definitely help you to granularly move your throughput of your infrastructure. So second thing is every VM has its own firewall as well as security policies at individual level. So as I said, so zero trust relationship and most granularity. How is it? It's been managed from NSXT, and how NSXT will take it up? It's helped with the help of distributed firewall at the VM level. So when you enable distributed firewalls, it's been enabled at the hypervisor level, or could be say at the ESX level if you are connecting with the ESXi host. And that ESXi host is being that distributed firewall is managed by the kernel level, and each VM which is there at the ESXi host are being governed with that distributed firewall. So that is something is being protected. So you can set a security profile on those VMs. Let's say something like a source and destination. I have these set of VMs will only speak to this set of VMs at specific port, and whatever the packets will get dropped out. So this is how you can specify at the VM level, at the VM NIC level specifically. So this is one of the most important thing which you can do it in distributed firewall. Security policies can be based on VM network application attributes. So you can define the policies and distributed firewall based upon factors. Like you can specify like VMs, what type of VMs you have. You can group those VMs and make a group of them, and you can specify that this set of VMs I require to have in the policies. It could be a network in the sense like you can put in specific IP addresses. This set of IP address will allow this set of IP address to communicate with them, or you can put it by the application basis. Like I have the web servers, set of group of web servers will speak only to these set of application servers. So like this, you can set the policies about in the distributed firewall. Security controls can be applied to any application at any point of time. So as I said that you can apply the security controls to any application. It doesn't restrict you to specifically allow any one of the application or two of the application. We have sort of VMs, sort of application which is there in the distributed firewalls options, which you can specifically, or you can customize your application which you would like to add it into that. So that's also an option to do within the distributed firewall. So microsegmentation in data center, NSXT, how it works. Microsegmentation segregate data into security segments down to individual workload VMs. Now let's see, you have this diagram. If you can see over here, I have a set of groups which is connecting to 3 VMs. Let's say I have a finance, I have HR, and I have engineering group of set of 3 VMs. And those set of VMs are connecting to the stateless services of the environment. Let's say the AD, NTP, DHCP, DNS, and CERT. So now let's say that any of the stateless services can communicate to any one of the groups. hey, you can go ahead and do that with the help of security firewalls. You can just say that this sort of VMs, this sort of group of VMs can specifically speak to DHCP. You can allow the services to DHCP on the specific VMs or on the set of VMs, or you can also specify that that group of finance VMs can speak to HR if they would like to, or you can specify that engineering set of VMs group cannot speak to HR or finance, as they don't have their own business to do that. Why do they will go for their to see all the payloads and other things? So you can segregate them into different groups so that only the set of VMs can speak within them themselves. As you can see that each VM is having its own firewall. This is what we have the capabilities in the distributed firewall. So every VMs have its own firewall. You can define it, which is at the VM NIC level. So it says that IO control and from NIC level, it's VM NIC level, the control of the firewall you have specifically at the VM NIC level of each VM. Each VM is having its own firewall. You can just specify what all permission you required, what security levels you would like to specify for the VM, and how granular you would like to make those micro segmentation of that specific group of VMs to other group of VMs. So it monitors the states of active connections and use this information towards the VM NIC. So let's say a VM, you have 4 NICs into that. So does it mean all 4 NICs will be part of a distributed firewall? Yes, they would be, because whatever the traffic which is running, whatever the active NICs which is there into the VMs are all included in the distributed firewall security profile sections, or they are active into that. So next we have attached the central control and operational distributed firewall directly to each VM. So that's it. It centralizedly connect and operate the distributed firewall at the VM level, not at any other, or not at the hypervisor, or you are governing your firewall at the VM NIC level specifically. See the difference over here. You're not installing any specific agent of antivirus or anything else. So it's completely agentless. So distributed firewall which you have installed level, the kernel level, it will allow you to do it at the VM levels and with the help of security profiles and rules which you have, which you create manually to as per your needs. So the use cases of microsegmentations, we specifically speak about NSX. It's protect your critical application environment with microsegmentations. So there are two ways you can speak it about. Critical application you're protecting, like if one thing in the way, like if you're having the perimeter firewall, if somebody jumped out or got attacked within the infrastructure inside it, this microsegmentation, which is, you can say, the distributed firewall, will protect you to get affirmative from the critical application, so that they will not get hampered, they will not get attacked by the attackers, so they will get secured. This is one of the most use cases. Second use cases is that, let's say if you have a set of applications, or like we have the HR application, you have engineering app set of group of applications or the group of VMs, that the HR would not be able to connect to the VM which is there at the engineering group of VMs. So there could be a microsegmentation within that, or could be, you can say, it's segmentations of the channels, or you can say the traffic which you're flowing as per the protocol or for the port level, or it could be the service levels. You can define that this side of source VM source could speak to a specific port or protocol. Other than that, when the protocols comes in, will get dropped off. So, yeah. So secure virtual desktop infrastructure, agentless antivirus with gas interceptions, and it creates a DMZ anywhere. So you have a set of groups, and that groups will get automatically connecting as treated as a DMZ anywhere. So this is how you can connect with that. So benefit of microsegmentations, it's limit lateral movement. As I say that if anything's jump out from the firewalls, from the fences within the network, it will protect you from the lateral movements. It minimizes the risk and impact of security breaches also. It simplifies network traffic. So whatever traffic which you have allowed in the security firewalls, it will only allow that specific firewalls. Use cases is infrastructure. It will use the topology which you have specified in the security firewalls. It lower the software-defined infrastructure as ADC, so it will definitely help you in that. It automates IT services delivery. So this is all which is helpful in that. And this all concludes the sessions of mine with the help which is NSX microsegmentation.
Hello, my name is Rich Colbert, Field CTO for Dell Data Protection. The topic of this presentation is how does Dell Technologies offer a low-cost data protection solution? Today, organizations are experiencing rapid data growth and diversification. Therefore, effectively managing the cost of data protection has become a priority. Data now spans the edge, the core, and the cloud across a multitude of applications and platforms. And in response, organizations are deploying and extending data protection solutions to protect that data and those applications where they reside. The saying that you get what you pay for still holds true, but in the multi-cloud world, it is probably more accurate to say you pay for what you get. In other words, consumption is rapidly becoming a leading factor in determining the costs associated with data protection. That leads us to the key point for our conversation today. Architecture matters. It's not a new concept. Technology innovation and progress has always placed a premium on developing superior architecture. But this is no longer an engineering conversation about building a better mousetrap. Architecture has a direct impact on consumption, and consumption is a leading factor in cost, along with a whole list of additional business values. What this means is that architecture is now a business conversation. And as such, there is additional focus applied to making the business case. It's no longer acceptable to simply compete with academic arguments in the marketplace of ideas. Architecture conversations need to be tied to measurable outcomes with validated metrics that impact the bottom line. These are the 4 pillars of the Dell data protection strategy that are the keys to our architectural advantage. The first is highly differentiated deduplication. Not all dedupe is created equal. And in this category, being second best simply isn't good enough. The second is distributed deduplication, also known as DD Boost. This innovative and unique approach to protection storage provides numerous benefits that we will cover in some detail. The third is our storage appliance architecture known as SISL, or Stream-Informed Segment Layout. This is our secret sauce to provide industry-leading performance and scale. Fourth, and finally, is our data and vulnerability architecture. At Dell, we haven't lost sight of the fact that it isn't just about managing data. It's about protecting data. When we say deduplication, we're really talking about compounded data reduction. Data deduplication and compression work together to reduce the amount of usable capacity required to store protection data. With daily backups retained for typically 30 days or more, data protection requires many logical copies of very similar data. In fact, protection copies can account for up to 95% of an organization's entire data storage footprint. So efficiency is the key to driving down the associated costs. Based on proven data domain technology, Dell's deduplication is inline with variable segments. Inline is important because it eliminates the need for a landing zone, which reduces the storage required in half right off the top. Variable length segments are even more important, and the smaller the segment size, the better. Our segment size is an average length of 8 kilobytes. Variable segments encapsulate changes in the data patterns to allow the system to find duplicate data, regardless of whether that data has been copied, appended, or even updated somewhere in the middle. And this algorithmic approach works well for both structured and unstructured data. But what matters to the business are the results. And how does that compare to the industry? Dell's technology is typically anywhere from 30% to 3 times more efficient than alternative solutions. And I'm making a direct and practical comparison. I'm talking about the basic question of how much usable storage is consumed and how much network traffic is generated to back up and replicate the data. What does that mean for the business? It means that one step further. What about the cloud, where you pay for your cloud provider for that storage consumption and that network bandwidth every single month? Protection storage on premises generally accounts for anywhere from 8 to 20% of an organization's total storage spend. But organizations who use ineffective data protection in the cloud can see those costs skyrocket to over 50% of their cloud infrastructure consumption costs. Dell Data Protection can reduce that exorbitant level of cloud spending dramatically. That is why effective data reduction matters. And that is why Dell Data Protection customers are protecting over 4 exabytes of data in the public cloud today. But no matter how effective your deduplication is, you give up almost all of the real benefits if you still have to send 100% of your data over NFS every time you back up. Backup execution can be broken down into 3 logical steps: process data, send data, and store data. When deduplication happens at the storage device, the upstream processing of sending and storing data is unchanged. And that is a whole lot of data to sift through and send across the wire every single day. A number of alternative solutions still use plain old NFS as a data transport. But distributed deduplication is a powerful innovation that takes the task of identifying. DD-Boost is an embedded technology, and it can be found in all sorts of places. DD-Boost can be found embedded in backup agents, both provided by Dell and by a number of third-party DD-Boost partners. DD-Boost can be embedded in VMware infrastructure, leveraging VADP and bringing source deduplication directly into the virtual infrastructure. DD-Boost is also deployed inside database backup utilities like Oracle RMAN or Microsoft SQL Management Studio and many others to bring the power of source deduplication to DBAs and application owners. DD-Boost can also be embedded in Linux and Windows file systems so that modern application backup tools can take advantage of distributed deduplication simply by utilizing their basic file export utilities for backup and recovery. So, what are the benefits of deploying DD-Boost? The first is faster backups. Backups using DD-Boost can complete in about half the time compared to backups that send all the data to the target. The second is network utilization. DD-Boost reduces backup traffic on the network by as much as 98%. Third is the performance of the backup storage itself. Many hands make light work, and therefore by offloading a little bit of work to hundreds or even thousands of backup clients, the overall performance of the data protection storage can nearly double when using DD-Boost. And the performance implication of running DD-Boost at the client is also significantly less than running a normal backup. And possibly the biggest payout is eliminating data movers. DD-Boost sends data from the client directly to the storage device, eliminating the complexity and the expense of running multiple backup servers to act as middlemen between the client and the protection storage. The impact to the business is tremendous cost savings on infrastructure. And there are also benefits to people and process. By enabling application backup utilities and elevating them to equal standing with central backup agents, organizations can share the work of backing up between the central IT folks and the application owners. And once again, many hands make light work. But the impact goes beyond the division of labor. Oftentimes, application teams are already doing their own backups to expensive primary storage. And then IT comes along and sweeps up those backups in an unreliable and redundant dump and sweep process. Organizations can now reclaim all of that primary storage and eliminate dump and sweep while maintaining application owners' ability to do self-service backups and restores. Backup and recovery stresses a storage system in a totally different way than a typical storage array. Primary storage is sensitive to latency and IOPS. Protection storage requires higher stream counts, and greater effective throughput. Protection storage targets can expect to see hundreds or even thousands of high-speed write streams at the same time. Dell Protection Storage, powered by data domain technology, is built with a unique set of attributes that we collectively call SISL, or the Stream-Informed Segment Layout. The first challenge this architecture addresses is performance. SISL is a log-structured file system that is append-only. This allows alignment with the underlying physical storage so that data is only read or written in full stripes. This also means no expensive data insert or update operations and no parity recalculations. The second challenge this architecture addresses is caching. In a normal array, caching applies to data that has been recently seen. However, in backup, and especially with deduplication, there's little to no benefit to caching recent data. Instead, it is far more valuable to prefetch data that the system is about to see again. This is the magic that makes high-speed inbound streams possible. With deduplication, the key to performance is the ability to decide quickly what to do with the data. Is it unique data that needs to be stored to disk, or is it duplicate data that can be referenced with a simple pointer? It turns out that the first question can be answered much more quickly than the second one. Once the system gets the slightest hint that a data segment is unique, it can stop comparing and start writing. It's the duplicate data that needs to be rigorously validated before determining that a simple pointer is actually appropriate. The SISL architecture uses some very clever memory structures to keep track of what's what, because while it is impossible to keep all of the data signatures in RAM, it is also incredibly slow to keep looking for them on storage. The innovative architectural approach employed by SISL is the main reason why the data domain platform has been able to hold its position at the top of the protection storage market, both in terms of performance and scale. But being purpose-built is not limited to a physical appliance. Data Domain Virtual Edition takes the architectural enhancements even further. Storage in the public cloud is very different from storage on premises. On-prem, block storage can be constructed with as much performance and resiliency as you want. But in the cloud, the public storage cloud providers have made object storage more affordable and more resilient than their block storage offerings. Data Domain Virtual Edition in the public cloud uses intelligent data placement to take advantage of the lower cost and higher resiliency of object storage, while also using a minimal amount of block storage when it provides a performance advantage. All the while, Data Domain Virtual Edition maintains the same effective deduplication that it provides on premises in order to max resort. Protection storage has an implied responsibility for data integrity and durability. If you are recovering data from protection storage, it just might be the last copy of that data that exists anywhere in the world. Dell Data Protection Storage has a group of native capabilities that we call the Data Invulnerability Architecture, or DIA. A number of these capabilities are a natural extension of the SISL architecture we just described. The data domain file system, which again is a log-structured file system, is append-only. Aside from the performance benefits, this also protects existing data from ever being changed by new data. Data is never overwritten, but instead is cleaned through an asynchronous garbage collection and performs read-after-write verification to ensure that data was stored correctly. Data in flight is also protected in NVRAM while awaiting write confirmation, so that any data that has been acknowledged by the system to the client is fully protected. The data domain file system is unique in that it validates 100% of the data it receives, but that's just the beginning. The file system is when data is read from the system, either as part of a restore, or as it's being replicated to another system, or copied to another storage medium. The data is once again validated and can be corrected on the fly if needed. The data domain file system also has some advanced security features. It has 2 levels of retention lock, which provide immutability and allows for the system to prevent accidental or without authorization from an independent authority. Also, cybersecurity is top of mind for many organizations today. And that is why we offer an enhanced solution called PowerProtect Cyber Recovery. With PowerProtect Cyber Recovery, we provide an air-gapped cyber vault that includes industry-leading capabilities to isolate, detect, and recover from a malicious cyber attack or insider threat. PowerProtect cyber recovery includes machine learning, data entropy detection, automated immutability, and nearly 200 powerful analytics to ensure your most valuable data is recoverable. Dell's PowerProtect cyber recovery is the only solution certified by the Sheltered Harbor Organization, the gold standard in financial information security best practices. Collectively, Dell views data protection storage as the storage of last resort. It has a special responsibility to ensure your data is safe and secure. When it comes to data protection, architecture matters now more than ever. Dell's unique data protection solutions provide unparalleled efficiency, scale, data capacity, and exceeding backup windows. I talked to many organizations who chose a solution based on a very compelling sales story, only to be surprised by the need to buy more capacity and more performance a very short while later, or to be surprised by an unexpectedly high cloud bill at the end of the month. At Dell, we want to help you avoid the hamster wheel of continuous and unexpected data protection expenditure. So we offer a solution that will be sized right the first time and that will truly deliver a predictable outcome with the lowest cost to serve. So most importantly, thank you. Thank you for stopping by and hearing about how Dell offers a low-cost data protection solution. We have a number of data protection sessions at this year's VMworld, and please check out as many of them as you can and as your schedule allows. We've got a few very exciting announcements, and I can't wait for us to share them. So have a great VMworld 2020, and let's keep your data safer together.
Catastrophic failure, tales from the trenches. I've been a vExpert for the last 3 years. I've also been for the last 3 years the Buffalo VMUG co-leader. You can reach me at Twitter and LinkedIn via the hashtag you see there. And I've been in the IT industry for about 20 years at this point in varying capacities. I used to be a web developer. I used to do some coding. I used to do some databases. I even used to do some help desk as well, which is what everybody should do at least once in their career. And I have moved up the tower to be a virtualization and storage engineer at Synacor in Buffalo, New York. And I would like to give this talk and let you know one of the issues we discovered when we went to do a NetApp maintenance. So if you've ever been at a bar with your friends, you're out drinking, you start telling war stories about, what's happened to you in your career and things like that. This is my story. So first of all, here's your beer, and I'm going to give you the story of what happened, and then we're going to walk through how it actually happened and all the troubleshooting that went along with it. So to give you the point of reference, my company has a DR facility located in Dallas, Texas. The facility is completely virtualized. That runs on a storage infrastructure of NetApp. We have about 250 ESX hosts. We have a DR vCenter, and we have a development vCenter that's hosted in the data facility. One of the DIM modules in our doing that, the technician, which we were in communication with on site, ended up pulling out the node to replace the DIM, as one does. And as soon as he did that, the rest of our environment completely dropped and went read-only. Our first assumption was he bumped the power cord, he bumped some fiber cables, he bumped the switch cable that's in the chassis, he knocked over a circuit in the rack. He must have done something. We come to find out within about 20 minutes that he actually didn't do anything. There was a bug in the specific version of ONTAP, which is NetApp's operating system that we were running, that had a specific version of motherboard firmware, and it caused a kernel panic in the NetApp node that was running and dropped that one and rebooted it. And that happened all within the span of about 90 seconds. So that then caused all of our DR environments and about a quarter of our development environment to go read-only. And then when the node came back up online, it was like basically pulling the hard drives out of all of our running VMs. We had kind of piecing our environment back together and learning a few different things in the process. So that is the story of how that actually happened. And this is actually what happened from the point in time we realized there's a problem until the solution came to be, which was some assistance through NetApp as well as a lot of our other teams on site. I'm telling you this because everybody's been in this situation before, and sometimes having a person tell you the story of how they solved it might help you in your environment. So the first thing that we start with is, uh-oh, something just broke. What just went wrong? We have to figure out how it broke, what happened. So our first set of questions, once we realize there's a problem, is what can I, as a virtualization and storage administrator, hit right now? What's up and running? What's functional? What pieces are a problem? And that obviously is your vCenter, your storage controllers, as well as your general administration boxes. Okay, now that we can figure out what we can and can't hit, let's figure out what scope this is. What data center are we in? We're in our DR facility. What cluster? It's our administration cluster, our production/DR cluster, and our development cluster. Next question would be, if you are a service provider like my company is, the next immediate question is, which clients are down? Do you have any revenue generating events? Do you have any people that are going to be calling you asking questions? Do you have any customers who are using your client's application stack for their own purposes? And the answer to that in this case was no, nothing like that in our production facility because it's DR. The next thing that we ask is our network operations center, always has a bunch of dashboards up. They're looking at traffic for our clients. They're looking at our data center facilities. They're looking at all of the different things that they are responsible for. So we ask them in chat, hey, we're doing a storage change right now. What do you see? What is going on your end? And unfortunately, in this case, the next screen I'm going to show you is quite literally exactly what they saw. Everything broke. Literally, their entire monitoring solution got overwhelmed with as many problems as they've seen. Because if you think about it, when you have 1001 VMs automatically go read-only, each VM could have up to 60 checks, if not more, and it just overloads the monitoring facility. So our network operations center currently is a newer set of employees that doesn't have a lot of experience. And as Fry is showing you, basically they thought it was the end of the world because they had never seen their monitoring solution break like this. So that's a little bit of an added stressor into what they started to panic and have all these issues come up. And they're like, oh my God, what do I do? And I and my team had to kind of walk them through, relax. We're all here together. Let's fix what's wrong. And then we kind of told them, here's what happened. Here's what we know of at the moment, and kind of brought them back from the brink. But it was quite funny to see in chat that a bunch of people just went, everything just broke. So first we had to tell them where the stack broke. And this picture is where myself and my teammates have control of. Our storage administration team and virtualization team control the following stack. We control the data center square footage, the power. We help the networking team arrange their equipment to be delivered, installed, and then managed at the data center co-location itself. And the network in our instance consists of fiber as well as Ethernet. We then move down the stack to storage. And in our case, we have object storage systems, and we also have block and we have file storage systems. Then that ties into our server infrastructure, which are physical machines, as well as physical VMware hosts. And my team's responsibility is the VMware side of that equation. Once you move down the stack a little bit further, you hit the guest operating systems. And the guest operating systems in this case are mostly Linux, CentOS, and a little bit of corporate infrastructure for the Windows. When we break it into the storage side of things, this picture is exactly the hardware that broke in the data center that I am referring to. So it's sometimes rare when you can see physically what actually broke, and it helps in presentations like this, as well as having good pictures of your data center. So our NetApp system was the one that went down. The block and file side of the equation went down. Object store was a different setup, so that was fine. And the picture right there is an AFF 8080EX, and the back of the picture shows the relatively well done wiring that the technician was working with. So we can immediately see that he could have hit a power cable for the switches, which are up top. He could have accidentally knocked one of the fiber cables offline to the node he was not replacing and working on. He could have hit one of the SAS cables, or he could have hit one of the power cables to the secondary node. As pieces have failed, which volumes are down, which network interfaces are okay, and which HBAs are okay. Everything from the NetApp point of view at the time when we checked seemed to be perfectly fine. All the volumes were online, all of the cards were up, all the NICs were up, all of the volumes and pieces, everything seemed to be fine until we checked the uptime of the cluster and realized the secondary node we had failed over to had rebooted, which shouldn't have happened. So the next thing we do is, okay, now we need to check DNS, make sure that's working, because that's usually one of the first things that we check. And DNS wasn't working. And then we move down to, okay, that's a virtual machine. Let's make sure our vCenters and our PSCs are functioning. I mean, they're FSCKs and come back up, rebooted perfectly fine, and we had network connection, and now we can start fixing our environment. In the time of about 20 minutes where we have gotten to this point, we now have our network operations center a little more calmed down. We are letting them know what's going on bit by bit, and we're feeding them information. They then ask us, as is our chain of command, do you need an incident manager? And an incident manager is responsible for communication between all of the following teams: the network operations guys, the database guys, systems administrators, email administrators, web operations portals, an internal program called VAM that we have, the storage team, myself, and then the network team as well, because all of the pieces of this data center broke. So all of these teams are going to need to have a person in charge of fixing their individual pieces. And an incident manager, while they may not necessarily be technical, always comes in with this face. They know nothing. They don't know what's going on, and their role isn't technical troubleshooting. It's being a frontline communication for all of these teams to ask a question to, so that these teams can do troubleshooting themselves. They also then report up in case this was a client impacting event. They would be responsible for communicating to the clients as well as our internal executives, who usually would start asking questions if it was a client impacting event. They are a very important piece to let the technical teams troubleshoot without getting bugged every 5 minutes. What's the status? What's going on? Why did this break? They are the front line in letting the teams that are doing the work do the work, as well as feeding the executives information they need to know, as well as the clients of the company of Synacor what they need to know. They're very good at what they do, but it's sometimes funny when they come in at 3 o'clock in the morning looking like that. So what actually broke? Here's a list of the VMs that we have. The left side is the DR facility. The right side that's expanded is the NetApp cluster that went down. So as you can see, organization is a very key part of your network and making it sure you can quickly see what broke where and how to fix it. So if we didn't have the data stores and the VMs organized like this, it would be very difficult for us to bring 1001 VMs back online after a reboot, because they went read-only, without knowing exactly where they broke and exactly which pieces went down. The right-hand side is actually especially interesting to note, is because that's actually our data stores. A lot of people don't quite realize that you can make folders for your data stores. And in this instance, if you have multiple different types of hardware, you can very quickly virtual administrators utilize And it makes for a very well laid out plan for day-to-day maintenance, as well as you can kind of see what things lie in different places. As I said, we had about 1,001 VMs go read-only, which means we now need to bring them back online with a set of reboots. And because vCenter is as it is, sometimes it's hard to make a large change like that. So we ended up doing a PowerShell script at the time I didn't know existed. You can actually do open VMRC, and it ends up giving you a quite wonderful screen of things that look like this. So you can bring up on your 50-inch monitors all of the VMs that you've rebooted and watch them reboot to make sure that they are FSCKing properly and bring them back up to functioning states. And every so often, you might have one that just gets stuck, and you can easily pinpoint it by having a screen that looks like this. You can also open a web console with PowerCLI, but I found doing the open VMRC a little bit easier because it sets, in Windows at least, a taskbar group for things that you can cascade, you can stack side by side, or in our case, you can just tile and watch them all come up at once. We broke it apart by doing our email infrastructure for the DR side into groups. So we did like SMTP servers, we did POP servers, we did exchange, migration servers, and we did our LDAP controllers all in separate groups so we can watch the bits and pieces come up. We also obviously brought up our DNS, our corporate LDAP, our corporate Active Directory, our corporate domain controllers up in the same way. It just helps if you group them all together, which, as I said in the previous screen, you can see on the left where those pieces reside so you can script against them. So now that we have our environment back up and running after a few hours, we can figure out what actually happened. And in this instance, NetApp jumped on immediately because we opened up a P1 case with them, as well as we had a early case open to saying, hey, we're doing some maintenance. So they immediately called us and went, this is something you should never see, is an emergency root volume not working properly when the nodes came back up. So they actually, to their credit, it's one of the reasons I enjoy working with the NetApp hardware, they called us immediately and said, hey, what's going on? How can we help you? What broke? We filled them in. We gave them a VDI to make sure that they had WebEx into the environment, and they started working and looking at how they can help us while we were bringing up our environment on the other side of that screen. They waited for about 4 hours. They did their research. They did their logs, and they found out that, as I had mentioned earlier, we had a strange issue of firmware versions on top of your OS versions being kind of funky. They said that this can be fixed with a workaround, which we then did. I'll show you that in a minute. And then they said that they also wanted to check our other prod facility and make sure that wasn't impacted. And it was to be fixed at a later date. So we now know that we had to fix that. So they were very, very helpful in working with us and being there when we needed them. And so we had, So we had the DIM, we had the panic, we had the root vol issue when it came back up, and NetApp did a quick give back once they did the thing. And here is the actual item that is the problem. The counter on the membership report sent, in our case, was above 1,000. And then our production facility, one node was affected and one node was not for further RCA. So that is the horror story that we have of that entire DR facility going down and being brought back. Thank you very much, and enjoy the rest of VMworld.
Hello and welcome to VMware SD-WAN by VeloCloud session. 5 ways VMware SD-WAN enables network transformation. I am Rohan Nagi, Senior Technical Product Manager at VMware. I also run SD-WAN 360 podcast. You can do a Google search for SD-WAN 360. It's one of its kind podcasts. I also co-authored a couple of books on SD-WAN. You can check on Amazon for those SD-WAN books. So let's go through our agenda for this session. 5 essential capabilities that SD-WAN delivers in here, which can transform your network using the VMware SD-WAN. So we'll look at how SD-WAN simplifies the deployment. But before that, we will kind of go over the problem statement, what the problem statement is with the legacy architecture. Then we'll kind of touch base on the SD-WAN 101, where you understand the components, how the VMware SD-WAN solution really works, how the architecture is. And that's where we'll go over those 5 essential capabilities like deployment simplification, application performance, security, what are the flexibility in the security. So with that, let's get started. I call this as IT 1.0, and that's where the legacy architecture comes to play. The traffic pattern, if you see, is very predictable. Response, and typically it happens over the private circuits, which is an expensive circuit which takes time to get it installed and configured. And then moving on, we started getting more and more public internet connection, but those were used kind of as a backup. So there is an active backup scenario. Not all the circuits were leveraged at the same time. So those created that complexity, and that's where I'll consolidate in the next screen for that problem statement. So like I mentioned, all the user traffic, getting backhauled to the data center where the resources are, but over the years, or even during this pandemic situation where users are working from home, we see that user locations are changing. At the same time, apps or your applications have started moving to the cloud. So your applications are now everywhere. There are on-premise applications, there are cloud-based applications. So enterprise networks are really not ready to work from anywhere. Like I mentioned, apps are moving, even the data centers are moving to the private cloud, the public cloud. WAN is really getting complex out there. You can see actually 50 to 80% of the traffic is backhauled. You have private internet. So these are some of the problems. But what are the real user concerns for user? Poor voice quality when they are using a business collaboration application like Zoom. At the same time, inconsistent experience when the user changes their location, let's say from branch office to working from home. What are the IT concerns? IT concern is to provide security when the users are moving, when they are using, let's say, different laptop. At home, I'm using my home laptop. How do I access these company applications securely, or applications which are in the cloud? And these leads to others, the hub and spoke model. Every traffic from these spokes, from these branch sites, has to go to the data center where the hub is installed, which increases the latency. So with the current environment, if we have to move away from this legacy architecture, what we want is the networking and even the security actually must come together to serve the user either at the branch or at working from home or from any location. And that's where SD-WAN comes to play. And I'll come to this VMware SD-WAN architecture, but let's do that SD-WAN 101. What are the basic capabilities for any SD-WAN solution? So the key 4 things are transport independence. What it means is, if you remember the problem statement, even when you have multiple circuits, we are using them in a primary backup mode, primary standby mode. But with SD-WAN, you'll be able to leverage all the circuits at the same time. And with VMware SD-WAN, all the circuits by default are in active fashion. So you are leveraging all the circuits, and that brings transport independence. Any kind of circuits you can bring in to VMware SD-WAN. The second key piece here is, now that I can use the public internet, what about the security? How do I access workloads in data center or in public cloud? So I need some kind of a secure overlay, and that's where VMware SD-WAN will build up secure overlay tunnel between branch to hub, branch to data center, where the hub is branch to branch, dynamic branch to branch, or even when the traffic is going to the cloud. And you might be wondering, traffic going to cloud in a secure fashion, and that's where VMware SD-WAN comes to play, and it shines because one of the VMware SD-WAN component, the gateway, it's in the cloud, hosted and managed by VMware. As a customer, You don't have to take care of that gateway. It has a global footprint. And we'll talk about that in the next slide when I kind of share the components of the VMware SD-WAN. And that secure overlay over public internet or private internet brings in the cloud VPN, where the VMware SD-WAN supports multiple topologies, like I mentioned about the hub and spoke, branch to branch. And at the same time, application firewall, there is an integrated firewall built into these edges which you deployed at the branch site or at the office, your home location. Now that we can leverage any circuit, security is in there. Who will take care of the link steering if there is any blackout or brownout condition? And that's where the third components come to play is the path selection or the application performance. That's the key. And that's the number one driving force for adopting SD-WAN solution, dynamic path selection. And with VMware SD-WAN, we take a further step away with our secret sauce, which is DMPO, dynamic multipath optimization. It will leverage all the circuits. It will break your single session, traffic session into per packets, into small packets, and it will send across multiple links. So your user traffic will go on all the available circuit, and on the other end, where the VMware SD-WAN gateway or the hub or any VMware SD-WAN data plane device is, we are going to reorder the packet. That's the key here. So per packet, sub-second, that's where this dynamic path selection comes to play. We continuously monitor all the circuits, and if there is any link impairments like latency, jitter, packet loss, we will adapt to it in sub-second fashion. First of all, I think the very key important thing here is you need to make sure that you detect it sooner, and that's where that sub-second comes to play. And we'll talk about this later in the slide. And the fourth key pillar is simple interface, simplicity, which is built into the VMware SD-WAN product. And this is where three key component comes to play: the management plane, the orchestrator. From a single place, you can manage and monitor your circuit. Edges, the CPU device, which could be hardware, virtual, which goes onto your branch, which goes onto your data center as a hub device. And then the third key piece, very important, is the cloud delivered, the cloud-ready gateways, which has a global footprint. So if I have to access any SaaS application, your traffic from the branch will redirect it to these gateways, and then we are milliseconds away to the SaaS cloud or to the internet using these gateways. So we have 1,000+ gateways across the globe. That's where, and why choose VMware SD-WAN? I think we talked about it. Cloud adoption, that's where the gateway comes to play. Assured application performance, DMPO, we talked about it. Simplification, simple, like zero-touch provisioning to kind of instantiate when I drop ship the edge device to your location. With simple clicks, you can zero-touch provisioning, you can kind of activate your edge device and you are ready to go. And then flexibility in the security solution. And that's where VMware SD-WAN comes to play. And now talking about those transformation, I think deployment simplification, that's the key we will talk about first. And this is where I want to show that zero-touch provisioning when the edge device is drop-shipped to your home or branch office. And this is where I'm going to kind of share a video and talk through it, what it is about. So as an enterprise admin, you will create a site from the orchestrator. And once the site is created, let's say the device is drop shipped to a remote location where a non-IT person will kind of unpack the device, power on the device, connect the internet cable to any of the WAN ports. You don't have to worry, or you don't have to call the IT support to which port should I be connecting to. So just connect the power cable, connect the internet cables, and then you will receive an activation link from the enterprise admin in your email. So just use your laptop, mobile device, or an iPad and connect to that email, access that email from that device, and that's it. It will get activated. Once it is activated, you don't need that non-IT person, or you don't have to call a remote admin sitting at that branch location to do any modifications or any configuration. You can do everything from that centralized orchestrator management plane, which is also sitting in the cloud, managed and hosted by VMware. It's again a multi-tenant in nature, the gateways and the orchestrator. So you can see the activation process here. Once it's activated, enterprise admin from the orchestrator can view that edge device, and they can kind of use that device to do the further configurations and monitoring piece of it. So let's move away from that video, and now let's talk about that DMPO piece of it. DMPO piece of it. This is where DMPO comes to play. Continuous 24/7 link monitoring we do, so we know at any given time how the links are performing. So we can do link steering in sub-second fashion. Even when we have a single link, we can do on-demand remediation and aggregation. First, we detect the application, because all of our edge devices runs a deep application recognition engine, what we call it as DPI. So today we can recognize 3,000 plus different applications. We already build up a secure overlay from the edge device to the hub device or to cloud where the gateways are, or from branch to branch. So all your application traffic which is going inside this SD-WAN overlay tunnel is continuously monitored, and we know at any given point how the links are working. Just to give you kind of a quality score, like a before and after. Before is where, let's say, your traffic has started flowing through this one of the ISP link out here. When you see these red and yellow marks, this is where the WAN impairments are happening. We will try to either remediate these situations, or we'll try to do the link steering if the other link has a better SLA for it. End-to-end, what you need to remember with the application performance is this key thing: continuously monitor, dynamic per packet steering, and on-demand remediation when you have a single link. With on-demand remediation, we do the jitter correction, error correction, automatic steering when there is a blackout and brownout condition. On a single link, we do the on-demand remediation for a brownout condition. And this is just a use case for a business collaboration application. Let's talk about the architecture for the cloud. Like I mentioned, one of the key components, the gateway, is in the cloud. Globally across the cloud, today we have 1,000 plus gateway around the globe, which has a footprint globally, and these are kind of sitting in the same core facility where the SaaS providers are. That's the key to it. So we are kind of milliseconds away to the SaaS cloud. And you can see here now from the branch, I can directly, the traditional approach was to backhaul to the data center and then go to the SaaS cloud. But now with these gateways, you can just redirect the traffic to the gateway and then it goes to the SaaS cloud. That's where VMware SD-WAN gateway comes to play. Flexible architecture, you can place there is no rip and replace kind of a thing for VMware SD-WAN CPE devices. They come in different form factors. VNF, you can have pre-installed on hypervisors. We also can instantiate these edge devices over the cloud. So any kind of topology is supported. There is no rip and replace kind of here. You can augment with your current topology. Even if you have a third-party kind of a router, you can place your edge device here and you can run a VRRP, or you could run it in a fashion where you have internet connections and the MPLS is going through the CE router for the service provider, and it has a pairing with the PE router for the service provider. At the same time, you can get rid of the CE router and you can use our edge device where it is terminating all the public and the private connections. And you can also connect to a non-SD-WAN site using this overall topology. At the data center, you can stack up multiple edge devices to form a cluster. And that's where that flexibility comes to play. When we talk about security, that's very important. We give multiple options. Like I mentioned, we have a built-in firewall, which takes care of your traffic inspection. At the same time, you can still use that backhaul to the data center where you are running the next generation firewall, let's say. So you can still use that legacy approach. There are still some enterprises which leverage that because of some compliance reason. You could also instantiate a third-party firewall on selected SD-WAN edge devices. and even those are supported. The fourth is the secure web gateway, where what you are doing is you are kind of, like I mentioned in the problem statement with the legacy architecture, the branch is running multiple network functions. So it's heavy, it's a thicker branch. So what we are doing is we are taking the complexity away from the branch and putting that in the cloud. So in this case, we are putting the security functionality like CASB providers like, Cloud Access Security Broker, or other functionalities of SASE, which I'm going to talk about there in a second. But what it means is we're taking the security functionality away from the branch and you are putting it in the cloud. So the SD-WAN task here is to provide you with the transport and the WAN improve CASB secure web gateway, web access firewall. All those things are there in the cloud, and SD-WAN will make sure that you have the WAN acceleration and connectivity to the cloud. And there is plus more, the visibility and the monitoring through Nyansa on the branch LAN side, and then the monitoring on the WAN side with the vRealize network, what we call it as warning. I think this is what I have for the session out here. You understood the problem statement, where the VMware SD-WAN comes to play, and what are those. Thank you.
Hey y'all, I'm Gina Rosenthal. I'm the founder of Digital Sunshine Solutions. And today I want to talk about building your own online adventure for VMworld. So we know because of the global pandemic, it is not possible to go to San Francisco or Barcelona this year. VMworld 2020 has to be 100% online. The good side of that is, yay, it's free, sorta. But the worst part of it is, man, I can't see my friends. I can't interact with people. I can't hear things live and feel like something really cool is happening. Or can you? There are ways to make an online event very interactive and make it feel real, build a world around it. But the very first thing you need to do is make sure you don't freak out. Don't panic. Just take a deep breath, breathe, and make your own adventure. This is possible to do. We've done it before, and we do it when we go in person to San Francisco and when we go to Barcelona to VMworld. We already make our own adventures. We don't follow the exact template maybe that is given from VMworld.com. We decide ourselves about how we're going to interact with the world that the VMworld staff creates for us for that week. So one thing to ask yourself is, how do you usually prepare to go to VMworld? What does that world look like? That's how we start any adventure, is by preparing for it. Usually the very first thing you'll do is register. Now that one's pretty easy because you just go to vmworld.com and register. And you can get a free pass, which never has happened before, to be able to see the sessions and to see the keynotes and everything for free. And yes, it's controversial. There's a premier pass. It costs extra money. That's where the good sessions seem to be. That's how you interact with the VMware experts. I could take a whole other hour to talk about that, but really that's just extra noise right now. We are on a quest. We are going on an adventure, and we've got to prepare for it. So try to set that unfortunate situation to the side for now. The other thing you do when you're normally planning to go to VMworld is you get your travel all set. You take a week and a half off. You plan your hotel, your flights. Maybe you take people with you. Maybe you do something extra on the side besides just going to the VMworld events. Because we know that's not going to happen this year. You have to block your time. We're going to, instead of VMworld staff creating a physical space for us to walk around, a physical VMworld, we have to create our own worlds online. And it starts with blocking your time. So for the last couple of days of September and the 1st of October, 3 days, that's when everybody's together. So block off your time. It's really important. The next thing we need to do when we're going on this adventure, we've done our planning. Now have to plan our campaign, or what parts of VMworld are we going to visit? That usually is separated into 3 big parts from me. Maybe you have an extra one that you would add in. But the places I would want to visit are some parts of the official VMworld planning. Some of it are the partner events and the partner sessions that they have, and all of the community things that happen, of course. So how we're going to build this world. There are 3 days globally that everyone is going to be checking out the new content that gets posted in the online areas, the big castle that VMworld has created. So this is really important to know what the exact time boundaries are. Do you want to go to keynotes? Do you want to go to sessions? How about hands-on lab expos? When are you going to do that? Is there a certain time you have to go when more people that speak your language will be there? I don't know. That's stuff you have to plan and check experiences. Going back to that idea of time and world building, since VMware is recording all of these sessions, time is relative. It means you can watch the sessions and the keynotes, all of them on your time at your house over your own internet. So why not figure out how to make that happen on your TV, in your favorite comfy chair, or your very favorite couch, with all the stuff around you that you like to watch sporting events or you like to have when you're watching a TV program. And then you watch that on your TV, then you have your phones out or your devices out. You use Twitter or Slack or text or however y'all normally communicate to make the more interactive piece come out. You can even meet new people doing this, either using those being open and using those communication platforms in an open Slack channel or in an open Twitter environment, or even on watch parties. Watch parties are where someone might stream one of the sessions with a group of people who are interested in the same topic, and everybody is able to communicate and talk. But it's a great way to meet people that are interested in you or seeing notifications about that. This is also, I want to talk about the meeting new people. It's kind of a big point. There's a lot of people who have never come to VMworld because of cost matters or distance matters or family matters or whatever, that are now able to be a part of it. So we can take all of that energy that we normally have at that world that gets created physically for us. We can bring that online. We can create our own worlds and create our own adventures to travel through those worlds and meet people we may not have even had a chance to meet before. That's pretty cool. Let's talk about another area to visit. We can visit the partner castles. They have extra sessions either on the expo floor or on either on the expo floor or on either on the expo floor or in a great location. So watch their Twitter accounts, watch their blog posts, find out what your favorite partners are doing. And if you don't see anything, ask them, ask your salesperson, ask somebody that you know at the partner, what are you guys doing for online? I want to include you in my quest. Now, we couldn't talk about VMworld without visiting all the community areas. Community is what has always bound VMworld together. This is how community is what has bound VMworld together always. This is how you learn new things. This is how you see new people. This is how you understand where the cool places to go hear new sessions are. It's all about community. Community people will let you know where they are because you'll see them in the same places. Twitter, maybe an email list, maybe a blog post. Watch in all the normal community places to see where people are and make sure you tag along with them or bring them along with you on your quest. A question I hear a lot about online events is, what about hallway? What about the hallway sessions? How about, there's a great dinner, you should come join and meet all these people I'm working with now. How do we get that if we're not physically all in one place together? You guys, we've always had hallways online. It's the places in the past in between. It's those communication methods that we have found so that we can stay hooked together with a hashtag or by tagging each other. Those are our digital hallways. All of the normal social media tools that you can use. And this year, there are more hallways to explore. I'd really encourage you to get a Twitch account, get a Discord account, play around and try to find the folks who are on VMware, on these platforms already creating VMworld content. I know I've created a Discord server basically to act as a hallway. There's several that I know of on Discord that are concentrating on VMware and of course VMworld. So go check it out, learn how to use the platform, and maybe that's another space where you can go on an offshoot of your quest. So the thing that everybody is missing and worried about is interacting with people and having that social feeling of being in this large crowd, but knowing that you belong there. So another question to think about as you're planning all of the places and all the ways that you're going to build your online world is, how do you usually interact at VMworld? I know how I do. I have lots of old friends and I'm not shy, so I make new friends every year at VMworld. This is important. Find your old friends. I know for me, there's a couple of Slack channels I'm on that have been dormant for 6 to 9 months that have all of a sudden started popping up, people trying to figure out what they're going to do for VMworld. Be the first to start that conversation. Find those new ways to make new friends, whether by figuring out how someone's going to be casting on Twitch or YouTube or using Discord, different places. Find all of that out so that you can meet some new people this year, just like we do every year at VMworld. The biggest thing of all, don't freak out because it's 100% online and you're tired of sitting in Zoom meetings and you don't know if you can take 3 days of that with VMware and VMworld. You can do it. You have to think big. You got to think differently. Think of this as different than 3 days of pre-recorded Zoom meetings. Think of this as the content is already there. Now, how do we interact with the people we want to interact with and learn more and see what's new in the future? How do we interact with people that could never attend VMworld again? Because this is pretty cool. Most of all, how do we connect everybody so we all can be building these adventures and we can have one great big VMworld? Speaking of connecting, connect with me. I'm Gina, and my email is Gina at digitalsunshinesolutions.com or gminx on Twitter. Would love to connect with you and figure out how we can interact at VMworld and share our quest. Thanks.
Hi, everyone. Welcome to this TED Talk, The Next Frontier, Deploying Object Storage with VMware Cloud Foundation. I'm Lawrence Chu from Dell EMC, and here's my cohort, Gopala, from VMware.
Thanks, Lawrence. Hi, everyone. Welcome to our talk. This is Gopala. I'm the product manager in VMware, focusing on stateful services and cloud natives. I would like to motivate the problem a little bit by talking about why we are building this platform and why we are integrating object stores on vSphere. What we're seeing is applications in the customer enterprises are changing. The applications that were consisting of a few VMs, depended on a few databases, were mostly easier to manage in the traditional space, are now becoming more complicated applications wherein you have not just one database, but these applications depend on a variety of stateful services, right? So object stores are the centerpiece of these stateful services and have become the de facto storage platform for these modern applications that are Kubernetes based, that use containers, that use all of these newer mechanisms like functions, etc. Object stores have become almost the de facto standard for storage for such modern applications. The reason we are seeing the shift is that developers no longer depend on a ticket-based system like they used to before for their storage needs. Rather, they use self-service S3 endpoints for their storage needs, and they directly deploy their stateful volumes and persistence over these object stores. So object stores are also very flexible in the sense that they will service big data applications, analytics applications, as well as regular test dev applications that need ephemeral storage. So object stores come up as a very compelling use case for our modern applications in the enterprise. Likewise, we also see several other applications like MongoDB, Cassandra, and other modern databases, Redis, Kafka, and such other stateful services to suit these modern applications requirements in the enterprise. So not just the nature of these applications is changing. We're also seeing a huge increase in the number of such modern applications coming to the enterprise. So you're seeing some of the statistics on the screen here. We are seeing that for the first time, the line of business is spending more on IT because they are seeing a huge increase in the number of applications that are coming in. And also, by certain estimates, we will see around 500 million applications in the next few years, right? So enterprises are spending a lot of time in developing these applications, and VMware wants to make it as efficient and seamless for these enterprises to build applications. And that is the reason we have acquired a few strategic companies, as well as organically investing in building this support within VMware. So what we are introducing today is the data persistence platform on vSAN, which is essentially a platform and a framework which we offer, where the ecosystem partners like Dell EMC can bring in their modern stateful services like object stores, and together this integrated platform and the service layer offer that simplified operational model, right? We offer developers that self-service, automated service deployment for administrators, right? So they get that simplified operations, integrated monitoring. And we are also introducing the vSAN direct configuration, which is allowing customers to go directly to the underlying bare metal devices that are attached directly to vSphere ESXi nodes to get that cost optimization and storage efficiency from these underlying storage. So in a nutshell, with this platform and the integrated services, our customers will be able to run these modern stateful applications like object stores with lower TCO. They get better bang for the buck from their storage. They're able to get their developers to innovate much faster, develop applications much sooner, and become more agile. And overall, their management and deployment becomes much simplified for their vSphere administrators while they're operating object stores and other stateful services on this platform. So I will hand it off to Lawrence.
Product line. So the reason for S3 compatible object storage, as you heard, really lie in the transformation of how applications are developed. Right now, we are now in a day and age where we have software-defined data center, and with Cloud Foundation, application users can quickly get access to an infrastructure, lifecycle management, and all the other automated service out there. But what about storage? What you're going to need is a reliable storage, such as the Dell EMC ECS, and object scale is such a target, right? Object storage is born of the belief that HTTP is the most ubiquitous protocol, and that practically unlimited global scaling is required to support next generation of application growth. Without worries about like mounting shares, fiber channels, or other such details, you're ready to start. We're now introducing the Object Scale Early Access Platform. It is a simple S3 compatible object storage. It is Kubernetes based. It's a scale-out software-defined product, and it's also multi-cloud ready. Dell EMC Object Scale Early Access is defined as. So how does it work? With vSAN and now with Data Persistence Platform, you can provision persistent volume and management of multiple of these storage services. So Object Scale builds on top, of this, vSAN and persistent volume foundation. So, and then we add our own internal databases, data protections, and many other storage specific features. Now, when you build application storage, it's exceedingly simple. So with objects, and in enterprise object everywhere, your applications everywhere can run object storage. This object storage is available, everywhere that vSAN persistent data platform and Cloud Foundation would operate. And with software defined, you can accelerate your development, because you don't have to pre-provision a dedicated appliance, which you typically only use none of it on day one. And you can spin up as much or as little storage as you want in your internal cloud environment. And lastly, it offers the same VMware experience. Use the same tools that all is done with provisioning. Then you can grow this storage as you need it, right? So Dell EMC, storage with either ECS or object scale enables you to have, like cloud scale, built with a scale out, geo-distributed architecture, so you can keep pace with the capacity demands, wherever your data center resides. You can have global accessibility. You can stand up, remove, add capacity for object scale wherever vSAN data persistent platform runs, right? So edge or in the cloud, right? Have your storage easily co-locate where your application runs. It's your choice. And you can utilize, existing resources, deploy on existing pool of virtualized infrastructure. You can secure, you can stay assured of the security and compliance, with what we have, such as data at rest encryptions, erasure encoding, and all such data protection schemes that we have. It allows you to have peace of mind. And lastly, it's enterprise proven, right? We are the same team that brought you the industry leading objects. Now accelerating, modern apps. What we're looking at here with cloud native applications, storage is not really one size fit all. Sometimes you may need more metadata services. Allow us to transparently scale up, down, across the appropriate services at the optimal ratios as you need them. And we take care of managing all the possible failure domains to ensure data availability and resiliency across all the physical assets that you have. Using the tools the simplicity of using the tools just cannot be overstated. I mean, obviously the benefits of running object storage containers on Kubernetes alongside your traditional virtualized resources in a single unified experience, and your ability to take advantage of automation that VMware Cloud Foundation gives you. And ultimately, it's really about aligning development and IT, right? Data center operators can use the tools they know to apply policies, assign quotas, and so forth, whereas developers can easily provision infrastructure services on demand while complying with IT data center policies. A couple of examples to just kind of give you like a feel of how you can take advantage of such a global archive, right? So your new application anywhere can directly store data on an object store and then have it, be replicated to all around the world. So say you have, and for traditional clients, what you see in the middle of the screen here is a GeoDrive, and it's one of the ways you can take advantage of this utility, which gives your clients, say Windows clients or Mac clients and so forth, an easy way to store data and present an efficient object storage as like a virtually unlimited file share available everywhere. Also, here's an example of how you could deploy it, right? So vSphere and vSAN are in many places now. And HCI is already available in edge and co-locations. And with vSAN persistence, data platform, you can now take advantage of any excess capacity and at any of these locations and easily turn those into a dynamic, scalable global archive, right? So all without the need. So let's quickly jump into a demo of our current early access. What you're looking at here is currently running, vSphere cluster, running the vSAN, data persistent platform, and within the vCenter, what you're able to see is what object scale running alongside other type of services, all manageable and seen at one place. So with object store, it's really easy to look at, what you have available and what state they are at. Right. So, for example, if you want to start a new object store, what we can do is just easily jump to the new object store. You type in the name, right? So you can decide on which encoding and protection you want. And for this particular demo, we can, for example, use vSAN, right? And then you just click next. And they give you a sizer, and give you some flexibility on how you want to, size up this workload. Depending on how many workload you may have, you can add, and then remove it. And these resources will done a customization you could choose as well, right? So at the end, Depending on how you want your workload size, by the amount of throughput, or other type of characteristics, then you can jump to, how other optional S3 services. So, for example, this screen allows you to specify, different service type, for example, load balancer, taking advantage of NSXT, for instance. And then at the end, you could review it. And then all you have to do is, but it is manageable, in the within the vCenter environment, all in one place. So I have some object storage that's already configured here. Right? So for example, creating new buckets, setting up the different users attributes, as well as certificates are really simple, all in one place. So you could easily manage events to see who has logged on and so forth in one place. And additionally, if you want to see how your object storage is performing, you can easily go to our Grafana dashboard, for instance, and you can load, for this particular cluster. But if it were, you'll be able to see, spikes and valleys, depending on the workload and the times you run it at. So you can do a lot of drill down, as well as, debugging, about your storage performance, very simply. So it gives you a very effective way of managing storage. And once you have the buckets, you can create the new buckets here, or you can create, new bucket, like typical with S3, say an S3 browser. Example, I just create a new bucket. I can easily create another new bucket here. I can, see, what are the different files or objects are in there. Right? So this way you can interact with them, very easily. It's just one example. All these are really RESTful. So now let's quickly jump back, to the end of our presentation here. So what we are, what we have here is, I just want to thank you all, for joining this particular tech talk, this quick tech talk about, object scale and coming to learn more about the vSAN data persistence platform. And if you have more questions, please, do join us on this early access, beta program. And use the link to enroll objectscale@dell.com. And let's show you what it can do.
Okay. Thank you, everyone.
Yeah, thank you. Thank you, Gopala and everybody.
Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're gonna talk about the NSXT 3.0 integration with Kubernetes. So this is the last CNCF survey from the last year, when Kubernetes users talk about their experience with Kubernetes, and also what they think that are the biggest challenge to use that solution. In this case, we have here the first one is like culture change. So the way that we deploy Kubernetes is a little bit different than using other platforms to develop. And also they have some challenge with security, complexity, and monitoring network. And from like the 6 major issues here, we can use NSX to address 4 of them. That's security, complexity, monitoring, and training. And this session, we're going to cover these 4 challenges here and also see how we can use Kubernetes in this integration. So Kubernetes use something called Container Network Interface, or simple CNI. And this allows that some vendors like VMware develop a third-party plugin to integrate with Kubernetes and deliver network. And NSX use this integration behind as the integration with NSX will be done by a component called NCP. That's the NSX container plugin. So in the left side we have Kubernetes, and in the right side we have NSX. And to do this integration, we're going to have here in the middle the NCP. NCP will talk API with Kubernetes and talk API with NSX. NCP is some containers that run, and the Kubernetes cluster will have some containers, some pods actually, that run in the master, and also others that run in the workers, and they will exchange, like they will translate. Kubernetes, we have namespace, and when NCP figures out that there is a new namespace in Kubernetes, it will tell NSX that a new namespace was created, and automatically NSX will create a segment to host that namespace, and also all the routing that's needed using a T1 gateway. And if it's a netted network, it will create also the net rules to a segment. So NSX will create a container interface and will connect that container interface to that segment, providing also the IP address to that pod and everything that's needed to communicate. Here in Kubernetes, we can deploy security rules, like we can enforce our security posture using a network policy, any network policy using the Kubernetes CLI, and also we can create the distributed firewall rules in NSX that will be applied to the pods that are running in Kubernetes. So both ways are fine and work well. Also, we have the ingress for load balance, for L7 load balance. This way, when also the load balancing rules to the pods, to the pool, and also the inclusion of that pool and that pods in a pool, all of them will be done automatically in NSX. Also, the service, like if you do like a service, layer 4 load balancing, we also can use the NSX for that, providing L4 load balancing for the pods. So to start this integration, we have Kubernetes that will deploy the pods, and NSX that will deploy the connectivity. So this way, NSX will be integrated to Kubernetes using a YAML file, and for everything that's created, it will be routed networking and also netted networking. We can also have the load balancing rules here and apply tags to everything. The way that tags work here allow us to create firewall rules based in tags based, and also load balance rules tag based. So when you tag a pod, when you tag like an application, automatically we include that pod or that application in a load balancing or in a firewall rule. So NSX will provide routing, switching, load balance, either L4 or L7, and distribute pod or a pod, pod port to a database VM, and check the communication between them. If you have like a firewall rule that's blocking the communication, or if the communication is working fine. So to start, we're going to create a namespace. The namespace will be created as kub control, create a source net rule. So Here we're gonna create the kubectl, create namespace vBrownBag, and here you can check the namespace was created and also the logical suite that will host the containers to that namespace. So the next step is to create an application. So our application will be called vBrownBag Application Controller. We have here two sets of replication controller. One is the web and the other one is the app. So when you create that, we will create two pods of each one of the replica sets, the replication controllers. Here we're going to apply the configuration, and we're going to check here the container creation. After a few seconds, everything is created, and you can check here that's all the four pods connected to that network, and everything looks fine till now. The next step is to create a service and an ingress. So the service will group like the similar that using labels. And also we're gonna, in this case, we're gonna have a service called web and another one called app. And also we're gonna create an ingress rule to load balance the external traffic to either web or app based in the URI. So everything that's /web will be load balanced to the web service, and everything that's /app will be by external IP for that application. So here we're gonna take a look in our service YAML file. So we can check here that we have two services, the web and the app. And based in the labels, we're gonna do the load balance. So here, apply the configuration for service. You can check the service and now the ingress. So we're going to take a look in the ingress configuration, and here we can see that we have /web to the vBrownBag web and /app to vBrownBag app. I'm going to apply this configuration to our namespace vBrownBag, kubectl get ingress, and here you can see that our URL vBrownBag.demo.corp.local is running. Here we can check the rules that match our regex for load balance. Here's the /app, and here you can take a look in the /web. Also the rewrite rule to /, and we can check if it's successful working, accessing our URL. I'm using here a private certificate, and everything's working fine for web. Now let's take a look on app, and everything looks fine also. The next and last step for this demo is the microsegmentation. So based in the labels, we're gonna provide the security for the environment. So we're gonna take a look in our configuration file, in the replication controller YAML file, and then we can see that all the labels have also been applied to the pods. And here, based on those labels, our file distributed file will enforce the security posture that will block the communication between web and app. We're going to take a look in the replication controller configuration YAML file, and you can check here that we have two labels, vBrownBag Web and vBrownBag App. Now we're going to check where those pods are running. So we're going to SSH to Kubernetes worker 1. And now take a look on the pods running there. And we're going to enter in the second pod. And to do that, we're going to start bash with other pods in the same network. So I start the communication with like a web container, then to the same web container, and then to app. And I can see here that the communication. And this group will use labels, tags, as will be tag based. So it automatically discovers what was created in Kubernetes. So here have the web vBrownBag. This will be our source, and our destiny will be the vBrownBag app. We also create a dynamic rule to include everything, all pods that has the tag app in the scope vBrownBag. Once configured that, we'll set the reject and publish this rule. Now I'm going to do the same test, and you can check that the communication between web and app doesn't work, while the web to app is still working. So this concludes this presentation. Thank you very much for watching, and see you next time.
Hello, and thank you for the time today. I'm Jim Shook, the Director of our Cybersecurity and Compliance Practice in our Global Technology Office for Data Protection. I spend most of my days with customers and internally talking about cyber recovery and cyber resilience. So I'm looking forward to having the opportunity to talk with you about those things today. In my presentation, we're going to talk about cyber recovery and how much can you afford to lose. You can't look at the news today without finding a bunch of stories about ransomware and data destruction. So we've got a couple here that are very interesting. And of course, we've blocked out the victims' names just because they've taken enough of abuse so far from the press. And really our point is to talk about what happened and how difficult it is to prevent and recover from these attacks if you're not prepared. So what you can see from these particular attacks are a few things. One, the attacks are very expensive. Losses in the tens to hundreds of millions of dollars for a ransomware or destructive attack are just not uncommon anymore. Two, it's very public. There are often service outages, the term here used as meltdown, that are evident to customers, to shareholders, to partners, and other interested parties. And three, the attacks have different types of techniques and capabilities. So you really have to be very prepared in advance for these attacks to minimize the impact. And despite that, despite the fact that we've had these attacks now for a while, you can see from our survey at the top of the slide that over 2/3 of organizations really lack confidence that they'd be able to recover their business critical data after one of these attacks. And that's certainly what we see too anecdotally from being involved in this area. So what do you do? How do you prepare for and recover from these attacks? It's interesting because it is really a cybersecurity capability. If our customers use a framework to kind of benchmark their cybersecurity capabilities, it's often, and this is globally, not just in the States, the NIST cybersecurity framework. We've depicted here nations traditionally, because we were worried about theft of data, which impacts the confidentiality of the data, focused on the other capabilities: identify, protect, detect, and respond. And those capabilities remain really important. We want to keep the bad actors out. We want to detect them as soon as they're in. We want to protect the information that we have. But we have to be aware that some of these attacks are going to get through, and we have to be prepared to recover from those attacks. That's our focus. So it's no longer just about the confidential, sometimes called a cyber resilience capability. That's really where we fit our practice and our solution. One of the first steps that you really need to think about when you're looking at how to protect against these attacks is to consider the full spectrum of cyber threat actors. So we've got various groups depicted here. Starting at the left, I think there's a little bit too much focus on basic criminal actors. So these are actors who are in it for profit. They often have the lesser ones have just cyber to be wary of more sophisticated actors. And thinking back to the headlines I showed you, those were sophisticated actors in those situations. And we'll talk more about their techniques, but they're in it for the money. We can't stop there. So insiders, nobody likes to think about their employees being bad actors, but it happens. People are involved. So our protections have to go beyond just the basic criminals and include insiders. Then as we move over to the left, particularly with hacktivists and with cyber weapons, the purpose for those bad actors is to destroy. So they may encrypt data just like a ransomware attack, but there's nobody to pay. So if you're not prepared with the ability to recover data and you get hit by a hacktivist or a cyber weapon, you can't count on the ability to pay a ransom and get your data back. There's simply nobody on the other side. So working across all of these threat actors, very important as you think about your strategy in the cyber resilience space. Here's one of the techniques that is getting to be better known, but really important to understand. Think about normal attacks. The slide I just showed to you. The bad actors are getting into the network, and ultimately their goal is to encrypt your production data, databases, servers, sometimes file shares, just the important stuff that's in production. And so if you have a backup, you might be able to recover from that attack. Well, the bad guys know that too. And so more frequently, they've been targeting the backup infrastructure as part of their attack. They're very resourceful. They have a lot of tools. What we frequently see is deployment of things like a tool called Mimikatz to pull in passwords. We're seeing more frequently the bad actors breaking into password vaults, and then they get all the passwords for all the infrastructure. So when they roll out their attack and they encrypt the production data, they're deleting, encrypting, or otherwise destroying the backup data. So you can't count on having that data unless you take extra measures. Another thing we see for some organizations is to simply put an extra copy of data, maybe an extra backup, in the cloud. And really the public cloud, if I'm being more specific. And that's an interesting strategy to have an extra copy of data, but it's not protected. It's just an authentication away. And we've seen some of these bad actors get into the infrastructure and watch what the administrative people are doing on a daily basis. So they're uncovering those extra copies. And since it's just an authentication away, they can log in and delete or destroy that data. We've also seen them leverage cloud data for their own recovery. So they might get access to that content and then they just do a recovery to their servers, and now they have all of your data. It's not a ransomware attack anymore, but it can certainly be just as painful. Similarly, a disaster recovery or DR strategy is a little different from a cyber resilience strategy. So think about DR and continue operations without too much disruption. Very important capability. Doesn't help us much in most of these cyber attacks because the capability that we have, we use replication to deliver that data to the additional site. That replication doesn't know if it's replicating good data, bad data, or encrypted data. So if the bad actors have gotten in and encrypted the production data, our replication mechanism just replicates that bad data to the next site, and so we lose that one too. So these are different capabilities. I'm not saying that DR and backup are bad. They remain as important as they ever were. They just meet a different purpose than a recovery or a cyber resilience strategy. At the same time, we want to be able to leverage those investments that our customers have made in their DR and backup strategies as stepping stone into their cyber resilience strategy. So that's where we focus. We've really been the leaders in cyber resilience. We've helped to set the market, set the capabilities that are out there. We have the most sophisticated solution and the most sophisticated practice. We also have the most customers, and that's important because we've got a lot of hands-on and operational experience. Another thing we've done in this space, and I'll touch on a little bit later, is work with the best practice groups that are out there, like the Sheltered Harbor Initiative, and we're the only ones involved with that process, which again, important from a standpoint of maturity and capabilities and sophistication. So what do we do? What is cyber resilience? What is cyber recovery for us? I like to say we could spend a couple hours on this, and I have on this particular diagram, but I'll just give you kind of a basic overview. Of course, we're all happy to talk with people in more detail about it at any time. So on the left, what we have is our traditional data center, very simplistically depicted production environment and the backup environment. Note, we don't have DR here, but people may have a second or third site. The other thing that we've done is we've color-coded some of the data. So when we talk about cyber recovery and cyber resilience, we're really focusing on protecting the most important data. That might be 20% or 30% of the overall footprint, just depending on the organization. We can certainly protect all 100%, but normally it's a focus on that most significant part. And so we've color-coded that here between the blue and green data on the left. So organizations are already making a backup. We're not going to impact that, but we do want to leverage it. And how do we do that? So our cyber recovery vault, our data vault, is on the right side. It has a couple of important characteristics. So one, it's physically separate. We like to have it in a locked room or a locked cage, but it's not another data site. It's at your production site. It's at your DR site. It might be with a managed service provider or even a cloud provider. Location doesn't matter. It's just that physical access that helps us protect against bad actors. And it's logically separated. So you can see in the middle, we've got this air gap, and we call it an automated operational air gap because it's not always off. We enable it sometimes so that we can update the data that's in our vault. So normal status are components in our vault. They run the vault from that side. We have storage, compute, and other components there. They're not accessible if you're in the production environment. They have private IP addresses. We don't share switches, firewalls, data diodes, our Unisys stealth capability. All those things can come into play to further secure the vault. What happens, though, is we want to take that most critical data, so the green boxes, if you will, on the left, and on a regular basis, we want to update the content that's in the vault. So we will enable that vault, essentially unlock it in a very careful manner so that's limited what can happen. And we'll go through these steps. Sync, we take the data from the production side that has changed from the last time we've done this process, and we sync it over into the vault. Then we lock the vault back down. We make a copy of the data, and organizations will keep that data from a couple weeks to a couple months, depending on their vault requirements. Then we'll lock the data. So we'll apply a retention lock to it, which helps to protect further against an insider or a failure of any type. It can't be deleted before the retention period expires. And then we'll analyze that data on a full content basis. And we'll talk about that a little bit more. But essentially what we're doing is we're looking at that data to make sure that it's valid, that if there was an attack, we could use it for a recovery. Out of all of this, we can get monitoring and reporting. It's automated. You don't need somebody sitting in the vault. It runs by itself and sends out information about the vault to your SOC or NOC or other monitoring groups. And of course, the whole point of this is if there is destruction or encryption in the data center, use the data that's in the vault to securely recover back to your production environment or another environment that you. One of the most important things that we've done is that we've built the solution out and we've productized it. And what I'm showing you here is the graphical interface for the system that runs in the vault. So if I can skip back for just a second, you can see the vault side. This is what runs in the vault, and the vault is controlled and operated from the vault side. That's really important because we make the assumption that a bad actor who's in the data center might have access to everything. Think about when I mentioned before about the insider. That insider may have access to everything, knows all about the vault, knows when it syncs up, how everything works, and yet we're still going to be secure from that type of a threat actor. And part of that is running everything automated and operating it from the vault side. The other great things about having a product is it's tested frequently. We have a help desk. There's a roadmap. We make improvements all of the time. And so you don't want to go out in this space and get a custom one-off solution. Also, as you make changes into your vault, you might change what's brought into the vault. You might decide that certain data sets aren't critical anymore, or they've moved. And being able to use this GUI, especially on the right side here with things like policies, to update that is all very easy and straightforward. And then you can see here too the recovery tab. We've automated a lot of the recovery processes. So if there is an attack, you know what to do, and you can do it at least partially on an automated basis to speed your recovery and make it as efficient as possible. A couple things that we've learned about cyber recovery and resilience that are important to a solution that's going to be effective. And again, tying this back to the whole spectrum of threat actors and the tools and capabilities that they have. So we think about this on a couple of different levels. And you can see on the slide here, good, better, best. And of course, you want to get further up as you assess the risks and the importance of your data in your environment. So good capabilities are things like making the data immutable. Some people will call that worm, write once, read many. There's a standard out there called 17A4F that people use to kind of take the place of worm. But essentially what we're doing is we're making that data harder for a bad actor to delete. So if they get into our backup environment, our infrastructure, we've locked the data. And note that I did say harder or more difficult to delete. Data that's locked really isn't immutable. There are ways to attack the data. There are clock attacks. There are insider attacks. So it's a good control that you want to add to a solution, but it's not a solution in and of itself. Then as we move into better, how do we improve our positioning there? Well, one thing is let's protect from insiders. So having those capabilities to separate the systems that an insider can't even get access if they know where everything is, putting physical controls on rooms and locks, separating duties so that different people can do different things. Those are all components of a solution that are important too. But as we get into best, this is really where we separate from everybody. And the key there is having that air gap, that operational air gap that separates the system from any bad actors that don't actually have physical access. And that's almost every case. So doing that alone is a huge step up from the good and better. I'd mentioned Sheltered Harbor before. There's not a lot of standards in this area. So when you look to how do we benchmark our capabilities or our solution, Sheltered Harbor is a financial services initiative that looks at a lot of these things and has some recommendations on it. We're the only group that's working with them in their technology solution provider program, in their alliance program. So that's a really great data point. And then the last piece is analytics. How do we know that what we put into the vault is good data? And then can we use that data when we recover? You think about some of these attacks, you don't know that it's locked up. Having analytics for your vault data can tell you immediately what data is good and what data is bad. So you might be able to use some of the data that didn't get impacted. You might know that some of your data from today is bad. And think back to my sync, copy, lock, analyze process. You may have a copy of an application, for example, from the day prior that's good, and you can reuse that versus having to go back and set things back up. So all that information leverages into the process of enabling your recovery to be more efficient and more effective. This is kind of my specialty area. I know puts some people to sleep, but what's happening in the regulatory environment, what's happening in the legal environment. And we're tracking along with those things. And in fact, in many cases, we're helping to drive those. So in the US, we tend to have more industry specific requirements, and healthcare and financial services really lead the way. They're talking about, you can see from the FFIEC, an air-gapped data architecture. Our FBI, which is a group that we get to spend time with here, is talking about backups and ensuring they're not connected to networks that they're backing up. So you think about those backups being attacked from my earlier slide, that's really what they're referencing there. Outside of the states, the protections tend to be more broadly structured. So they're not going to be sectoral in an industry, but things like the GDPR, which protects personal data, actually has some cybersecurity requirements to it. And just fascinating to me, again, GDPR has been out for a few years, that they mention what I talked about before, confidentiality, integrity, and availability of the data, not just the confidentiality, which is the theft, but if you're going to have that data, you've got a responsibility to make sure that you can use it and that it's secure and available. So this is the path that we're working down. And when you think about how these all coalesce, it's an air-gapped copy of data that's protected in the data vault. That's the best way to meet these requirements as they become more structured, more strict, and more important in the coming years. So when you look at the competitive differentiators, and this is similar to the slide that I showed you before, I think it's important to understand what else is out there and where it may fall short. So in many cases, what we see from others in this space is just taking a backup and hardening that backup. And as I said before, things like immutability, which you can see across the top row here, it's important, it's useful, but it's not a solution. It's just an extra control that's going to make that data a little bit harder for a bad actor to reach. We're operating across all of these different capabilities, and they're all very important. So as you look at other solutions, really understand what they do, what they don't do, and where the gaps are going to be. They're going to protect typically against the, I mentioned before, garden variety bad actor, and not against insiders, not against being informed on all these capabilities and determining what's necessary for you to really keep a safe copy of data. I talked a little bit about the analytics and want to talk a little bit more. So how do you know that data in the vault is good? And that's what we do with our CyberSense capability. So think about the sync, copy, lock, analyze. We're bringing data in to the vault. We don't care if it's good or bad data. It's not going to run in the vault. So if there's malware in our backup that we're bringing into the vault, or there's dormant malware, it doesn't run. It can't impact our vault because we're keeping it in this backup format. But we want to know, is the data good? So what we do with our analytics is we take that data once it's in and locked into the vault, and we scan it. We don't have to restore it. We can read through the backup format, and we're going to make some observations, some statistics on all this data. We're going to go at an operating system metadata level. Did the size of the file change? Does it have an extension that might indicate it's been corrupted? We're going to look at the application metadata. So think about a database having an actual structure to it, that if that whole structure is gone, then that data is corrupt. But then we're also going to look at the full content. So we're going to measure things like Shannon entropy that might tell us that data has started to get encrypted. We've got chunking and similarity algorithms that will help us compare files day over day. We're going to take all that information and feed it to a machine learning algorithm that's going to help us understand whether that data has been corrupted. So no, we're not looking for malware. We're looking for evidence that the data is not useful. We repeat, we do that day over day. We have all these comparisons, and then we've got all that information available to us. So we'll send out from the vault a simple report card. Data looks good, data is suspicious. And then if you go into the vault, you can look all the way down to the file level to every single observation that can get you all the information you need to help determine root cause and help figure out how you're going to recover. Really important. I mentioned before the critical data. So as we work across industries, every industry has different focus areas. You can see a few here. I spend a good amount of time in the financial services area. So banks and credit unions looking at core banking. Some are looking at trading platforms. In the legal community, document management is really important. All data is going to be important at certain levels, but what we're really looking to protect in the vault are those critical data sets that without you really do not have a business. You can't operate at all. So get those into the vault and make sure that they're protected. I've mentioned Sheltered Harbor a few times. I think it's a really good organization for people to look at for best practices. Shelteredharbor.org is the site. If you're in the U.S. banking and financial services industry, you can be an actual participant. And I think it's a good evaluation to make. It helps protect the U.S. financial system. If you're not a potential participant, the ideas that they have, and you can see here on the right, for example, how they require a data vault, the characteristics that are necessary to protect data are useful. So the unchangeability, the separation of the data, make sure that it's accessible. All those components add up, and there's more technical requirements there that are really useful. We're looking forward to winding up our last step of our endorsement process this month, which is August 2020, and continuing to work with the organization and their participants out there. So just kind of wrapping up here, why Dell Technologies for cyber recovery? I mentioned before kind of some of the specifics here. The air gap is hugely significant. Just making data immutable or locking it is a good step, but it's not enough. All of our experience in this space, really good. 5 years. We know what we're doing. We've made changes to the product over time to reflect some of the new techniques. And then the analytics in the vault, going full content. All of those things really add up to a very robust solution. We've got a lot of other materials out there on our website, videos, case studies, white papers. Recommend that to you also. So I want to thank you very much for your time. Look forward to the opportunity to maybe speak with some of you in the future, and be safe and take care. Thank you very much.
Hello, everyone. My name is David Santos. I'm an NSX engineer. And today we're going to talk about VIO, VMware Integrated OpenStack, and NSX. How a VIO is an easy button for OpenStack deployment, also with the NSX providing the network. So here we're going to talk about the architecture, the VIO architecture. In the middle, we have VIO, and it will be consumed by Horizon. That's the project that provides the user interface, the UI interface. We're going to consume our infrastructure as a service. And in the back, we have the VIO products. We have Nova for computing, and in the VMworld, the Nova will be provided by vCenter and ESXi. Here we have a benefit of using VMware as our Nova project, because vCenter will be the single endpoint for all the Nova workloads, and also have native VMware features like DRS and vSphere H8 that helps with the availability of the environment. And we have Cinder as the block storage. In the VMworld, Cinder will be provided as our data store. So every time that we use a data store, it will be use it as a Cinder block storage. Neutron will be provided by NSX. Like Nova, NSX has a benefit that will be the single endpoint to deploy networking, like layer 2 switches, routers, load balance, and firewalls. We also have Glance. Glance is the image project for OpenStack, and in the case of VMware, the Glance will be the VM templates that will be used and that will be consumed in VIO. So before we start, we need to deploy some objects in NSX. In this case, we need to deploy a T0 router, and also we need to exchange the routes between T0 and a physical router using BGP. This way, everything that we deploy in VIO will be automatically distributed to the physical infrastructure. So after that, we're gonna have our first step, that is to create a local network. In this case, we're gonna create a local network called Local 1, and we're gonna connect two VMs in that network, Web 01 and Web 02. So here I have our network topology. I'm gonna create the local one network, create a subnet for that network that's called Local 1 subnet, and also provide the IP address for that network. And it will automatically use the first IP as the default gateway when you create that. And now we're going to connect our Web 01 and Web 02 to that network. Web 01 already connected, and now we're going to connect the Web 02. And now I have already layer 2 connectivity between those VMs. And I'm gonna connect to the Web 01. It asks for changing password because the first time that I connect to that. And now I'm gonna ping to the Web 02. And you can see here that the ping is working. So the second part is to create the routing network. So to do that, we're gonna create a router in VIO in the NSX, and like under the hood, what will be done is NSX will be configured to create a new T1 gateway, a new T1 router, and also we're gonna use the T1 router to provide connectivity between the local one network that has just been created, and to local 2 network, where we're gonna have our other VM that's at 01. So here in the routers tab, we're gonna create a new router here called VIO router. And then we're gonna access that router and go to interface, add a new interface, select the network that will be connected, and it automatically will use the first IP as the IP for that router. And that will be our default gateway. You can check in the topology that will have our router connect to local 1 and local 2. Now I'm gonna connect the Apple 1 to that network. Apple 1 is already connected to the local 2, and it gets its IP address automatically using the HCP. And if I do a little ping here to my Web 02 or to my Apple 2, the ping works successfully. The third step is the external network. So the external network is kind of an IP pool that will be used as a floating IP or like external load balance IP. It doesn't create a real network. It creates a pool that will be consumed and will be used by this T0 to provide net or to provide or to deliver those IPs to our objects that will be published externally. So as it's an external network, we need to do that in the VIO admin level. So this way we can share that network with among all the projects that we need. So I need to go to the admin level, go to network, and here I'm gonna create a new external network. I'm gonna call that network external, select the project, this way, in this case will be admin, and it's a local network, but I select here shared and external. I include here the subnet name that will be used as our pool name, and also the IP address that we cannot set the DHCP rules in the external network. And here you can check that our external network has already been configured. The fourth step is the floating IP. So the floating IP will be done by connecting that T1 to our T0. Actually, you're gonna connect that T1 to the external network. That what is showing. That's what is shown on the VIO console, and it actually is will distribute the floating IPs that we assign to the VMs here. So when you create that, it will create a source NAT rule to all those VMs communicate with an external, with an external network using a source NAT IP, and also to the ingress traffic, the traffic that comes from the external, like the physical network. We need to provide a floating IP to those workloads. This way, we don't need to redistribute or to share the internal networks with like a physical network. It helps a lot when you have like bubble environments or when you have vertical subnets, sharing only the floating IP as a common network. So this way we're gonna go to routes. It has to be done. It has to be done in the project level. And here in the VIO router, I select my external network as my source, my way to the to external create floating IP. So I have 50 floating IPs available. I'm gonna allocate one to my project and associate that floating IP to my WebO1. After associate that, I can successfully do an SSH to that VM. And here I will log in and try to do a little ping to my app VM, and the ping will work as it worked before. The fifth step is the load balancing. So we're going to create a load balance that will be placed in the T1, and our pool members will be WebO1 and WebO2. So I also need a floating IP pool to do that. That IP pool will be associated to our load balance later. I go to neutral load balancer, create a new load balancer. I can select here a name for that load balance, select which subnet will be connected, the load balancer protocol, that in this case will be HTTP, also the port that will be used, and the method, in this case will be round robin. Here, select the pool members that will be WebO1 and WebO2. Also can select the port if it's another port, the monitor. I can select like get to a specific URL or an object. And it's really simple to create a load balancer. After that, we need to associate that load balancer to my floating IP. And once that's associated, we can you can see that's load balancing across Web 01 and Web 02. The last step is the sixth and last step is the security group. So security group will be delivered by the NSX DFW. So in this case, we're gonna create a an ingress traffic to HTTP, like to a web application, like Apache or any Nginx. And I will associate that security group to my Web 02. That my Web 02 is in the full security group now. If I try to ping my Web 02, it works. And if once I change my security group to allow HTTP and block all and remove the default, I can check here that the ping is no longer working. So I can see the packet drops here. And that's all I have today. Thank you very much for watching. See you next time.
Hello and welcome to this talk. I'm David Espejo. I'm based out in Colombia, South America. And I've been part of the vBrownBag community for quite some years. So I really appreciate the chance to share these topics at VMworld 2020 Tech Talks. So let's get started. In this session, we will talk about a little bit on distributed systems theory and why it is important for us in IT, right? So first of all, theory, right? That sounds really academic, and it's really academic. So first of all, why? Why to bring this topic from textbooks, from academia to IT? Why it is important? Well, first reason, it's because distributed systems are all around us in the everyday systems, products, protocols that we use and consume every day. They are all around us. And in my experience, this academic topic is not open for the interpretation of a specific vendor. It's a concise, exact, precise topic that when it's clear for us, and that is the main goal of this session, to try to bring light on how these topics can be found or can be traced to most of the systems, protocols, and products we use on the day-to-day operations of an IT environment. So examples of distributed systems will be VMware or VXLAN. And even Netflix, it's a planetary scale distributed system that happens to provide streaming services to end users, right? So they are all among us. So now if that is pretty much clear on the why of the importance of this topic, what is a distributed system? For most of these definitions, I will reference the textbook by Professor Tannenbaum, who is very famous. He wrote several textbooks that are used throughout computer science schools throughout the world. And he provided some definitions for this topic. So first of all, a distributed system, it's a collection of autonomous computing elements that appears to its user as a single system, right? So there's a lot there to unfold. I will try to unfold a little bit this definition. Examples of distributed systems that operate like the textbook definition are, for example, a vSphere cluster. You have several nodes. Let's say a node in this context can be a hardware device or a software process. There will be several nodes that appears to its user as a single system. You log into vCenter, you see a cluster. A cluster itself, it's a form of or an implementation of a distributed system. For example, NSX has most of these services are distributed by nature. So it's a collection. There are several components. And one of the principles is that each component could act or could operate independently from each other. But in the practice, they will need to communicate, right? You have several components, but they will need to communicate to achieve a common goal. So the next feature, the next base feature is the single coherent system. Its users are not aware of the distribution of processes, services throughout many nodes and many systems. No, they will see or they will operate this as a single system. This is not the same as having a single view, right? If you are thinking about the infamous single pane of glass, I will dive a little deep on this in the next slide. It's not the same. It's just the coherency here comes by providing the user an experience in the system that behaves exactly the way the users expect it to behave, no matter where it's deployed, no matter how it's consumed. It will respond to user requests exactly how they expect it to answer or to respond, right? And for me, this has a lot to do in the trade-off between complexity and abstractions. You know, most of the promises that technology do today is providing simplicity, right? Eliminating complexity, and complexity cannot be eliminated. So the formal definition for complexity is shown there in the presentation. There was another professor called Herbert Simon. He provided a formal definition for a complex system that happens to be one made up of a large number of parts that interact in a non-simple way. So it's very similar to a distributed system. We can say that a distributed system, it's always complex, right? But simplicity, it's not just removing parts, because the system make the system appear as a single coherent system, right? So that is the abstraction, the most realistic goal with a complex system. Well, so let's dive a little deep on the base features. First of all, a collection of autonomous elements. If you have several elements, they will need a way to communicate between each other, to exchange messages between them. And also, if you have different independent components, nodes, or processes, more likely each process will have its own notion of time. There is nothing like a global clock for a distributed system. So you will need a way to provide time coordination. And also, if you have several members or several nodes to form the system, you will need a way to manage membership. You can have an open group when whatever node can be part of the group and can send messages to all the members of the group, or you can have a closed group. And if you have a closed group, you will need a way to authenticate a protocol to authenticate nodes, to accept nodes into a cluster, and once accepted, to provide authorization on or trust on which part of the groups it can communicate to. So the technical or academic definition for this problem is admission control. So it sounds very familiar to a vSphere HA cluster, which happens to have an admission control mechanism. So examples of these requirements or these features for distributed systems implemented in the day-to-day components we use in IT, it's, for example, AMQP or RabbitMQ, a protocol, a messaging protocol used by some VMware products. or NTP, the Network Time Protocol, and a way to provide time coordination for a distributed system. Active Directory, for example, an example of authentication protocol to accept or deny requests to join a group. Single socket layer, TLS, etc. Different ways to provide trust for this collection of independent elements. And the single coherent system, as I was referring previously, it's not the same as a single system view. It's not the single pane of glass. That is a fair goal, but it is harder to achieve than just to say it. So it's the trade-off between appearance versus expected behavior. And the coherency here has more to do with expected behavior than with appearance, right? So the overall goal is to hide the complexity, but the most important goal is that the system behave exactly like its users have designed it to behave. Right? When you have different components, you will need a way to provide services for these different components. That is being called middleware. And middleware provides at least 3 functions to a distributed system. First of all, communication. It will provide mechanisms to communicate components of the distributed systems. It will provide transactions, a way to manage transactions, because most of the times an application relies on different services that are distributed along many nodes or components of the system. So the scalable way to manage that is by using transactions. And finally, reliability, a way to handle partial failures. If you have a system made up of different nodes, you will have to face the reality. A part of the system will eventually fail. So how to hide the partial failures of the system from the users? You will need a way to handle rapidly or have a way to tolerate failures. So you will see this in operation in an HA or high availability event in a vSphere cluster. It's just a way to restart automatically VMs in another node. That is a way to hide or to manage partial failures of the systems for the user. So examples of middleware services are, for example, RPC, which is a design pattern of today's applications, relies on communication between components provided by an API, which happens to be kind of a middleware. And also serverless. Serverless work only with transactions, probably atomic transactions, but those are transactions provided by this, let's say, middleware layer that are necessary for a distributed system. So in summary, that's it. In my opinion, when you gain more knowledge or at least study a little bit this distributed systems topic, you will get a better idea on how to design an IT environment, and also it will set your expectations at the right level on how it operates. So I appreciate the chance, and I hope you like this talk. Thank you for watching.
Welcome to this vBrownBag session deploying SQL Server 2019 big data clusters on Kubernetes with Ansible. Today, we're going to explore one of the many different ways to deploy a Kubernetes cluster with the end goal of deploying a Kubernetes application, in this case, Microsoft SQL Server 2019 big data clusters. My name is Doug Bernhardt. I'm a senior principal engineer with Dell Technologies. I've been at Dell now for a little over 8 years, and I've been working with SQL Server for over 25 years. Storage is obviously a very critical component of a big data or database environment. So now my primary focus is SQL Server and storage integration. While I've managed to hack out what I needed in VMware to get the job done and learned a fair amount about Kubernetes, Ansible, and Linux along the way, my primary background is SQL Server. My journey to Kubernetes and Linux and tools such as Ansible was one of necessity. Since my background is primarily SQL Server, my main goal was to deploy this new application knowing that I needed the method that we're going to cover to be very well suited to my needs. Over the coming days, you'll surely hear a lot about forward-looking concepts and what's new in vSphere 7. This session is not about that. We're going to walk through a basic deployment of Kubernetes that's on a very simple environment of good old ESXi and vCenter. Also, keep in mind that there are literally over 100 different distributions to Kubernetes, as well as various different deployment models. This is a deployment of open source Kubernetes, or what is often referred to as vanilla Kubernetes. To perform the deployment, we're going to use basic VM templates and Ansible open source playbooks. Finally, we will deploy a big data application, Microsoft SQL Server 2019 Big Data Clusters. There are various use cases for this deployment method. Maybe you're not ready to go to 7.0 just yet, or perhaps you want a similar deployment process and tools for bare metal, cloud, and VMs. This deployment method is similar to what you might use to a paper at the end of the session that covers everything in detail. SQL Server Big Data Clusters is a big data and AI platform that deploys a data lake in a box, as I like to call it, on Kubernetes by running a single deployment command. As part of that deployment, application components, including SQL Server instances, Spark, HDFS, and tools such as Grafana and Kibana are all deployed as Kubernetes pods in a single namespace. Since we're working with a data application and containers are ephemeral in nature, the deployment will dynamically provision persistent volumes, somewhere in the range of 28 to 50 or 60, depending on how large you wish to scale the cluster. Because we're working with big data, some or all of these volumes could be several terabytes in size. Knowing Kubernetes is required, I want to use vanilla Kubernetes. I quickly realized I needed to figure out a way to deploy, and this was prior to the latest offerings from VMware. My research quickly led me to different solutions using Ansible. For those of you not familiar with Ansible, a little background. Ansible allows for agentless automation. So you install Ansible, and it allows scripts or collections of scripts organized as playbooks to be run against one or more targets. One of the great things about Ansible is that the scripts are designed to be rerun without harm, if needed, to achieve a desired state. If the target is already in the desired state, then the scripts will simply find nothing to do. There are various modules available for all sorts of operating systems, cloud environments, and hardware platforms, and a very rich library of existing playbooks and samples that can be leveraged. In my case, I was able to find a couple of open source playbooks to accomplish what I needed, customize the parameters for my environment, and execute these playbooks for deployment into the Kubernetes environment. So let's take a look at that now. Here are the high-level steps for this process. First, you'll need to install Ansible if you've not already done so. Next, create a template Linux VM to be used as the deployment source for our multi-node cluster. In this example, I'm using RHEL as my OS. The important thing here is to find an OS supported by kubespray, which most Linux distributions are, and then to use an OS that is supported by the application, in this case, SQL Server Big Data Clusters. Also, in the template VM, you may wish to pre-pull packages that will be downloaded, install tools, etc. Next, Kubernetes will be installed using kubespray. Kubespray is a really cool tool because it not only automates the deployment process, but supports a lot of different options such as networking types, cloud providers for storage, Linux distributions, and is therefore really customizable by just changing the config parameters. Finally, we can deploy our application, in this case, SQL Server 2019 Big Data Clusters. Now that we've covered the steps, let's quickly walk through a demo of this entire process. The first thing that needs to be done is to build a template to use when creating the cluster VMs. This will be used as a consistent starting point for all of the VMs in the Kubernetes cluster. It's a process that most VMware users are familiar with. You create a VM in the state that it will be the starting point for your VMs in the cluster. Then you shut it down and convert it to a template. Some tips for setting up the VM template. If you take away one thing from this session, it should be this. When working with Kubernetes and vSphere, make sure to set the disk enable UUID property to true. The persistent storage driver uses this to identify storage resources, and if this is not set, persistent storage provisioning will not work, and the errors may not be clear as to why. When you're finished with the template configuration, after you shut down the VM, remove the network adapter. The deployment scripts will add it back and configure it, but they may not work properly with an existing network adapter. Since setting the disk UUID property is so important, Let's quickly run through how to do that. Select a VM, in this case the one to be used as a template, and go to Edit Settings, VM Options, and then click the Advanced section and choose Edit Configuration. Here, choose Add Configuration Params and enter disk.enableUUID for the name, true for the value, and click OK. Once the template is ready to go, you can deploy the VMs using the VMware Guest Ansible module. First, you'll need to install Ansible if you don't already have it somewhere. It's agentless, so you just install it on a machine that has access to everything you wish to automate. And as I mentioned earlier, Ansible has several modules that know how to communicate with various infrastructure components. Using this module, you can start with an existing playbook or write your own. I happen to find one to start with on GitHub that you can pull down as a starting point and simply customize the parameters, so that's what I'm using here. The way this playbook is written, I have two configuration files, one with the common settings and one with the settings for each VM. In this case, I'm using a file called answerfile.yaml to specify the VMware environment settings, as well as some common VM settings. As you can see, there's a section for my vSphere environment specified, as well as all of the common guest settings. In another file, I specify the settings for each VM I want to deploy. Ansible has a concept of an inventory file, which is a list of items to configure. In this example, the inventory file is called VMs to deploy. In here, I'm specifying that I'm going to build 5 nodes, 1 master and 4 workers, giving each its own name, IP, and notes. Now, running the command Ansible playbook and passing in the inventory file and the playbook name, this will deploy the VMs. Each VM was deployed as a task. The result is listed in the play recap section, where we see that each VM has a status of OK and changed equal to 1, showing that the deployment changes were applied. A properly written Ansible playbook can be rerun without harm. So here you can see where I reran the script and it just simply came back with everything OK and changes equal 0, so no changes were applied. Now that the VMs are deployed, the Kubernetes cluster can be deployed on top. In this example, I'm using kubespray, which you can read more about on the Kubernetes website, and pull the source from the GitHub link listed here as well, but it's the same idea. Pull down a set of playbooks, customize for the environment, and run. The biggest difference here is that since kubespray offers several different options, there are a lot more parameters that can be specified, but it's still fairly straightforward. First, we need to build the inventory file. This is what the inventory file looks like. We're specifying the names of the Kubernetes nodes as well as the connection information. So this file needs to be updated with the info for all the nodes of the cluster. Next, you need to configure the persistent storage, which in this case, we're using vSphere data stores. This is all done in the all.yaml file, which you can see here in the center of this file is the cloud provider, and is set to vSphere, as well as the vSphere credentials and parameters. From here, kubespray will deploy and configure the vSphere cloud provider. But for now, this method works just fine. Depending on what other Kubernetes features you want to modify, such as the overlay network, Kubernetes version, etc., these values can be specified in the other configuration files as well. Just look at the documentation to find the location of the feature that you wish to change. Finally, we run the Ansible playbook command above, and it begins deploying the Kubernetes environment. This is a rather lengthy deployment because it does a ton of work. In my environment of 5 nodes, this takes around 15 to 20 minutes for this process to execute. Once the deployment is complete, the Ansible play recap shows all of the changes that were applied. The final step before deploying the application is to create a Kubernetes storage class. This references a storage provider installed with the cluster, and it points to the data store we wish to use as well as the file system. Here's an example of the storage class definition, and it's created using the kubectl command. Now that the cluster configuration is complete, we can deploy our application, in this case, SQL Server 2019 Big Data Clusters. At this point, the hard work is done, and it's just a matter of following the Microsoft documentation on installing VDC. Because the Kubernetes platform abstracts the infrastructure details, The deployment of BDC is pretty much the same process regardless of the Kubernetes environment. To deploy BDC, we install and run the AZ Data utility provided by Microsoft. This will deploy the entire cluster into a namespace consisting of several pods, services, and persistent volumes, which are dynamically created based on the storage class we provided earlier. As the deployment progresses, you will see various progress messages as the various components come online. After all the components are deployed, the cluster deployment will be complete. At this point, the entire deployment is complete and the big data cluster is ready for use. Now you use Azure Data Studio or your tool of choice to connect to the cluster at the cluster endpoint that is provided here during deployment. The call to action from this session: get more familiar with Ansible if you don't already know it. It's a great tool for configuration and deployment and something super handy to have. Also, deploying Kubernetes with kubespray is a great way to learn about all the various components that make up the Kubernetes environment, and it can be used with physical, virtual, and cloud. This is just one of the many different ways to deploy Kubernetes. Each one has its own personality in terms of tools, ecosystem, and integrations. There are full details of today's demo in the Dell EMC paper mentioned here. This paper is on our new Dell EMC PowerStore appliance, but the steps can be applied to almost any VMware environment. Finally, enjoy the rest of the VMworld presentations. There will be lots to come on new Kubernetes features and capabilities in VMware, specifically around vSphere 7.0 features. This concludes this vBrownBag session for today. Thank you very much for attending and have a great day.
Hi everyone, my name is Karol Boguniewicz. I'm an expert and engineer from VxRail technical marketing team at Dell Technologies. The topic for this session is vSphere and VxRail REST API. Get started in an easy way. And if you open that, then I assume that you're interested in RESTful APIs. And that's why I wanted to make it more practical for you. Instead of preparing slides, I thought that such a short time allocated, I will show you an extensive demo instead. And I'd like to show you three main things. First, how you can start your API journey by leveraging an interactive web-based API documentation. Second, how you can use these APIs from different frameworks such as scripting with PowerShell in Windows environments and configuration management tools such as Ansible on Linux. And finally, how you can consume these APIs virtually from any application in any programming language. Sounds interesting? Well, let's dive deeper into that. So let me start the demo. So probably the easiest way to start your API journey is to use the interactive web-based documentation for that. We're leveraging here a Swagger framework, which is an open framework for API development, very popular in the industry. And we've designed those APIs in the way that they are complementing vSphere APIs. And you can just go to this URL from the VxRail manager and you can choose, there are 12 different groups of APIs available in the 7.0 version. I'm not going to talk about all of them, just a few of them. So if you choose the spec for LCM, that will provide you with the functionality for the automated lifecycle management, which is a huge differentiator here with value add. If you go to support, you can change the support features such as support account or maybe remotely collect the log bundles for the system. If you go to the system, then you can collect very useful system information, including health, etc. To start interacting with that, you just click one of those API calls and immediately it expands and provides you with the possible response codes like 200, 400, etc. and also the example values that these APIs would return. And you can also check the model. This will show you the data model that is used by the API, so you will know what kind of information that you can expect in return. To try it, just click Try It Out button and execute. This one doesn't have any parameters. And you immediately see here that we got code 401. That's an error message that provided vCenter credentials are not valid. And that's actually a good thing because we haven't authenticated against the system yet. So that's a good thing that it prevents you from authorized access to the API. To fix that, I'm going just to authorize using my vCenter credentials. So administrator and password. And you can check the authorization status with the lock icon, which is now closed. We try that again. We can see there's a corresponding curl command URL. And right now the response code is 200, which is success. You can see the response in a JSON format, very useful information about the system VMs, health of that, how many hosts in the cluster, etc., etc. And a typical scenario, if you'd like to manage the infrastructure remotely, you would need to collect some inventory information. And you can do that with the hosts API available from the host category. You can check the value model. We can try this API. Again, we can see the returned the response, and this provides a lot of useful information on all the hardware components in the system. In a similar way, you can consume vSphere APIs. Also, the same approach, web-based interactive documentation. Just log into vCenter, go to the Developer Center, and then you can choose the API. In this case, we'll interact with vCenter, so choosing vCenter API. And for instance, to get a list of VMs on the system, I will choose the first one, get REST vCenter VM. I can provide the simplicity. I will just use the default. Let's execute. And immediately you will see also the corresponding curl command and also the response. This time it also includes the information about the data model use. And let's take a look at this CentOS 7 VM template machine. Because in a typical scenario, you're going to have a golden image from which you will create multiple VMs. You will have a pre-installed operating system with all security settings and software. I've copied the ID of this VM because I'm going to now clone this VM from this template. There is an API call with the action clone. I can populate the parameters using the data type, which is shown on the right. Now, as a source, I will provide this VM ID that I've just copied. Let's immediately turn it on. And I'm not going to modify too much in this clone, so maybe let's, instead of using default name, provide a specific name for this demo. I'm going to change the placement. It will be the same location as the template itself. Very simple, clear example here. I'm going to execute. I can see the curl command. I can see the response. In this case, it's an ID of the newly created VM from this template. I can check that from the VMs and templates view. I can see that this clone indeed was created. It has been powered on and available. So that was a very quick start with the interactive web-based documentation. What if you'd like to start your API journey using the available automation frameworks for scripting, etc.? Well, the API cookbook will be handy for you. You can go to that. It's available on the support site. And let's see some very simple example. Let's check the system status. We did that already from Swagger. We're going to do the same. And you can see that we have multiple examples here in curl, in PowerShell and Ansible. So let's start with PowerShell. PowerShell is now available on most of the modern Windows systems, a very popular scripting framework. But you can also use, of course, the REST-based calls, but it's better to install the necessary modules because it just makes things simpler. In this case, I've already installed the Israel API, and you can see that it installed multiple namespaces corresponding to those different API groups that I shown you from the web interface. So let's copy this example. Let's copy the DNS name, in this case, of the VxRail manager. Let's provide the authentication information again. And we receive the same output that we see from the web-based interface. To make it more human readable, I can provide the convert to JSON commandlet, and now it's formatted for me. I can check the list of all of the commandlets which are available in this module with the Power CLI if you have ever used that. So let's take a look that you can do similar things with the Power CLI, but we will talk to the software stack that is built into the system. So I imported the Power CLI. Immediately I got some getting started information. I've listed all of the commandlets, and there are currently hundreds of them, almost 900 automation commands. When you combine that with what we provide with VxRail, you in total get more than 950. Very powerful. Now let's check the Ansible example. So I've installed the CentOS system here. I can check the Ansible version installed. I already copied this example and changed the environmental variables, and I can run this playbook. So using this different framework, this now configuration management framework, I get the same result. I can check the system information. Now let's take it further. What if you'd like to consume those vSphere and VxRail APIs virtually from any application, any programming language? Another tool, Postman, will be handy here. VMware provides several examples on how we can consume vSphere automation APIs using Postman through the collections. They are available on codevmware.com. I've already imported them on the system. You can see them here, vSphere automation REST samples. You can browse through them, and for instance, you can check VM create with details, which is an example how to create a new VM with a lot of detailed parameters from REST APIs. In the body tab, you can see the past parameters that you need to provide. So I wanted to show you a quick trick how you can use the same approach, but with the VxRail API. When you go back to Swagger, when you use this hyperlink there, when you save this file, it actually saves the API specification, which you can import as a collection to Swagger. So we can use that in the same way. So I'm going to import that with default settings. I'm importing that, and immediately I have a folder with this interface. There is one more variable that you need to set up in the environment here. It's base URL. You can copy that variable from the Swagger. And again, we need to authorize against the system first to provide the vCenter server authentication details. I'm providing those here. And now when you send this call to the VxRail manager, we get the same output nicely formatted in JSON format. Now, if you'd like to do that from other programming languages, this is where the code functionality is helpful, because it can generate code snippets for you in different programming languages, including C#, Java, JavaScript, Node.js, PHP, Python, and many, many more. So let's try the Python as an example. I'm going to copy this automatically generated code, paste that into the text editor. I'm going to add one additional parameter, and this is really just to disable the check of these certificates. And immediately I can get the same output from the Python that we could see in the previous examples. This is really powerful. So let's recap. In this session, I walk you through how you can easily start your API journey and how you can use vSphere and VxRail APIs together from the same tools to get more value. We discussed how you can explore and interact with these APIs from the web browser, PowerShell, and other automation frameworks. And finally, I've shown you how you can integrate with these APIs from virtually any application in any programming language using code snippet generator in Postman. I hope you found it interesting. Please give it a like if you like that, and feel free to reach out to me with questions. Thank you for your attention, and have a great virtual VMworld.
Thank you for taking the time to look at to view my vBrownBag session that I'm going to record. It's how to use vRealize operations as you're monitoring single pane of glass. I work for Select Medical, and we're located in Mechanicsburg, Pennsylvania. I am a V expert for 2020, and if you look at my slide deck there, I do have my Twitter handle and also the address to my blog if you would want to reach out to me after you view this. A little bit of my background. I've been using the ESXi for quite a few years, vRealize operations, for over 6 years. Create a lot of custom dashboards, reports, alerting. Been using the True Visibility Suite. Also do a lot with vRealize automation. So I'm going to show some demos, that whole single pane of glass, how you can integrate the two together. And just real quick with the V community, I've been involved since like 2013. Started by just going to some local V mugs, and then I thought I wanted to give back a little bit. So I've done some presentations at some HVC events. I've done a power block and also talked at some Little Hacks. And if you haven't gone to a Little Hack, those are really good. You should try to get involved locally if you can. So to use VROPS as your single pane of glass, there's a lot of really good built-in stuff right out of the box. Some really good dashboards, alerting, and reports. And then once you become more familiar with it, start creating your own dashboards and your alerts and start looking at super metrics. And then you can use it for troubleshooting, right sizing. If app teams ever come to you and say, I need more CPU and memory, there's some really great dashboards to get the proper size of your VMs, or to even show costs to your managers. If somebody says, hey, I want to move this to the cloud, there's some really good dashboards on showing the costs on-prem versus the cloud. So that's, I keep saying that single pane of glass. I mean, there's so many uses with VROPS. And then to start extending VROPS, instead of just using everything that's built right out of the box, they have what they call management packs. So if you go out to marketplace.vmware.com, there's some that you can get, and that'll start expanding the capabilities of VROPS. Some examples are some of the storage companies like HP or EMC have some management packs. So not only can you monitor your hosts and your VMs, but now you can start getting a lot deeper into your SAN environment. So that's, that single pane of glass. And what really made me think about the topic of my presentation is when I started looking at the text display widget. You can with that widget, you can link to internal URLs, external URLs, website widgets. You could show weather maps if you have a lot of SaaS applications. A lot of them have like a status website of how well they're doing, and you can link to that. And what you can't do with it is you can't alert off of any of that data. It's really display only. But my use case was to create VROPS to be that single pane of glass for our environment, and just to show data from many different sources. Here's some examples. I said I do a lot with VRA also, which is vRealize automation, is I create some websites that I link to with VROPS that show our server builds, or if we're going to decom a server, or we let app teams do snapshots. So I have these dashboards that let us see what other teams are doing. So, it's that one place to go for monitoring, and you can use it for more than just the data that is collected out of vCenter. So here you can see like our server builds, I show the server name, the IP, all that information right in that dashboard. And the way I do my automation is most of it is with PowerShell. So like for doing server builds, when it's done, I create a static web page that I put out on a web server, because I store the data into a SQL database, and then I create this website. And it doesn't matter what the web server is. If you're a Windows web shop and you want to use IIS, or if you want to use any other kind of web server, it doesn't matter. And I kind of got the idea because if you go to my blog site, I've been using Hugo, which I've been pretty happy with. And what I do is I take all those pages I create with Hugo and I save it to my GitHub repository, and I use GitHub Pages to display that. And that, when I started using that, it's like, that'd be a great way to do VROPS. So that's what I do. And what management does in our environment then is they're always going to VROPS, is that single pane of glass, to see what we're doing with automation. So it's that nice little integration. Then with VROPS 8 and VRA 8, they did a really good job right out of the box that you can integrate the two together. So if you do a deployment, and let's say you give users access to only VRA and not VROPS, you can still integrate those. And if you look in there in my slide deck, you can see I'm showing the performance of the VM. So there again, it's always going back to that one single pane of glass that you can pull in all the information. And thinking outside the box a little bit with the text display widget, we have two different data centers. And one of the things I thought would be kind of nice to show is the weather from each. One is in Pennsylvania, one's in Texas. And then like for Pennsylvania, I even show the radar map. And that's all within VROPS, that you don't have to leave VROPS if you're in there monitoring your performance all day long. And I just thought that was a great way to show that, because if you display this on, let's say you have a NOC center and you have a whole wall of TVs and you want to be able to show the people inside your NOC, hey, this is what the weather's like outside, because most NOCs that I've been in don't have windows, and it's kind of thinking outside the box a little bit of what you can display. Ever since everybody's on my team has been working from home, we're really big users of Zoom, so we use that for video chats and chats. So Zoom has a status website. So there again, I use the text display widget to link out to Zoom, and it shows the status. Just this past Monday, Zoom was having some issues with some people weren't able to join some video conferences. So some of my team went to this dashboard that I have, and they immediately seen that, hey, there's some alerts that Zoom's saying there's issues. So, you know, it's always that single pane of glass. I keep saying it, but, you know, try to think of that's where you go to do monitoring and check performance. You know, I'm even showing an example there of AWS. There's a lot of SaaS applications that people have, and as long as they have a status page available, you could look at showing that. And there again, you could even show that in your NOC. You know, everybody's working from home. One of the things I didn't always know was when were the people actually working on my team, if they were taking a day off. So our developers internally created a web page that shows information from Kronos. So they sent everybody the link, and I'm like, man, that would be a great thing to include in the VROPS, since we're in there all day long monitoring performance, is to create this link. So you can see there, I can go out at any time and see who's working and which days. And when I talked about right sizing, you know, in addition to monitoring, you know, if an app team says, hey, I need this much CPU or this much memory, after you're monitoring your VMs for a while, it tells you what they should be, you know. So if they're asking for a lot, you can say no, or maybe it's even the opposite. Maybe they don't have enough CPU and memory, and that's why they're complaining that it's slow. So there again, to use that single pane of glass, now you're also using it to set up things correctly in your environment. One of the new features in version 8 of VROPS that I really like is the troubleshooting workbench. So, you know, you're monitoring, you're kind of seeing how things are, but then to go out here and do your troubleshooting. Here you can see all the different layers in your stack, and I really like how they do the red, yellow, green. You know, if VM is having issues, go and look at this right away and see where your issue. If you see red, you know, that's where maybe you should start looking at first. If things are showing green, you know, don't spend time in that area. So there's also many ways to show this information to your users. You can set them up as a user that they would sign into vRealize operations directly. In a NOC environment, if they sign in as a specific user, what you can do is give a list of which dashboards that you would want to display, have them auto-rotate, and what's going to display next, and set a time on there. If you have workspace 1 in your environment, you can create catalog items that are linking to dashboards. And if you just want to send somebody a quick link by email, you could do that. And if you look at my slide deck, when you create these links for people to see outside of VROPS, you can even set a time, and you can say it's good for 1 day, a week, a month, or never expire if you're doing it on like a company portal or something. You can take the embedded information, and that's what I'm showing, and include that into other systems. I mean, everything I'm talking about is bringing data into VROPS, but you can do the opposite too if you really have to. Here's what it looks like in Workspace ONE. You can see like where I work, we give a lot of links to all the VMware products, even some products that aren't VMware. And then this makes a nice little area that everybody comes to, that you don't want to set them up as a user, but you still want them to see the dashboards. You can do that with Workspace ONE. And then what you can do is set up what they call categories. And I have a category that's called dashboards. So I take all my VROPS dashboards so to quickly see which ones are dashboards, groups them all together nice. And this would be like if you're in a NOC environment, or even working from home sometimes, I have an extra monitor that I'll sign in and actually have like a NOC type environment in my house that you can say, display this dashboard, and then, do the auto transition, turn that on, say, keep it on the screen for 180 seconds, 3 minutes, and here's what to display next, and just have these screens. So if you're on a NOC and you have a whole wall of screens, you can kind of set up some really nice, if you don't have enough screens to show all your dashboards, just set up some rotation and set a timing on it. Works really great in a NOC. So a quick overview. Just think of VROPS as a place for that single pane of glass that you can display more than what it's collecting from vCenter. The text display widget, just think outside of the box. I really think they should rename that to the cool shit widget, because if you can display weather and websites that you create internally, it's really good widget. And then all the different ways that you can display the dashboards to users. It's whatever works best in your environment. So, I should go out and start creating your own single pane of glass. If you want to see what I'm working on next, just follow me on Twitter @DaleHassier, or go out and check out my blog site. It's vcrocs.info. So thanks for watching. I hope you learned something, and reach out to me afterwards if you have any additional questions. Thanks.
Welcome to the presentation on Cloud IQ, how to debug your VMware installations on the go with Dell EMC Cloud IQ. I'm Susan Sharp, Cloud IQ Product Manager. Cloud IQ provides you intelligent insights about your infrastructure, particularly by providing proactive monitoring and predictive analytics. One of the key advantages that we have with Cloud IQ is the human intelligence regarding the Cloud IQ ecosystem, leveraging the strength and power of the Dell technical community. That includes the developers and architects who are actually developing Cloud IQ, along with the product team developers who provide product-specific subject matter expertise. It also includes the support engineers who bring forward breadth and depth of vast subject matter expertise, knowing that special thing to look for, or the things that you need to proactively be aware of, so that you can better understand your environment and take actions to address potential risks before they become real issues in your environment. And it also includes members of your Dell account team, whom you can invite to be trusted advisors, so that they can also see the insights that Cloud IQ provides and help ensure you get the very best from your Dell infrastructure. We hired a third-party evaluator to compare Cloud IQ to some of the other products out in the marketplace, and they found that time and time again, Cloud IQ demonstrated an ability to allow users to reach faster time to insights. So hopefully you'll see that benefit too when you use Cloud IQ. When we talk about Cloud IQ, the three main pillars we talk about are reducing risk, planning ahead, and improving productivity. So I'll tell you a little more about each of those. We'll start with how Cloud IQ can help you reduce risk. One way that Cloud IQ can help you reduce risk is with the proactive health scores that you see here, where we provide a per system health score that will quickly identify systems that are at potential risk and also provide the recommended remediation to address that potential risk so that you can avoid real issues in your environment. We also have a unique performance impact analysis and anomaly detection capability that allows you troubleshooting all the way from the system level all the way down to the VM level. And this is where I will showcase this capability of Cloud IQ in the demonstration portion of this session. Along with this impact and anomaly detection, we'll also identify workloads that are in contention of the system or pool resources and need to be redistributed to remove that bottleneck. Cloud IQ also allows you to intelligently plan ahead. This was a key area where, with the ability that Cloud IQ provides for predicting capacity reaching full, we're able to provide an almost 10x advantage for our users. Cloud IQ provides both a short-term capacity full prediction as well as longer-term capacity forecasting, so that helps with both risk avoidance in terms of avoiding a data unavailability and also providing intelligence in your ongoing planning and forecasting tasks. We also recently added the ability to detect capacity anomalies. Think of this as a run-on-the-bank scenario and enabling you to avoid that 2 a.m. phone call when all of a sudden your capacity has reached full. Additionally, Cloud IQ enables you to improve productivity. One way of doing that is by the fact that Cloud IQ has a breadth of data center support. Cloud IQ supports the majority of all Dell storage assets as well as Connectrix switches and is integrated with VMware. I'll give some details on that in the next slide. I also mentioned the trusted advisors. With all of us needing to do more with less, think of leveraging your trusted advisors for the additional expertise, additional proactive monitoring for your environment. Customers can simply invite members of their Dell account team to be trusted advisors, and that will enable them to log into Cloud IQ as well as you to be able to look for potential issues or potential areas of risk that need addressing. And finally, because Cloud IQ is hosted in the Dell private, secure infrastructure, you get immediate time to value with Cloud IQ. Once you've set up your Dell storage assets and connected via remote telemetry, you can log in to cloudiq.emc.com and start viewing Cloud IQ and your assets. Cloud IQ integration with vSphere obviously starts with vSphere. And then we have a special Cloud IQ collector. Think of it as an aggregator of the key vSphere telemetry. That then gets sent to the Dell Secure Telemetry Gateway. So all of the left-hand side is on your premises. And then that Secure Telemetry Gateway then sends the telemetry into Cloud IQ for preliminary ingest and analytics. And then that information is displayed in the user interface, the browser or the mobile app. This Cloud IQ collector is available for download from the Cloud IQ application. So you can simply click to download the collector app. I'll show you when I shift over to the demo, and then you can simply set up that vApp and start collecting the data, the telemetry data from your vSphere instance. So with that, let's shift into the demonstration. So I talked about the user interface and the Cloud IQ mobile app. So let's talk about how you would use those with your vSphere and VMware infrastructure. So here's the mobile app. And on the mobile app, there's a special area here that will draw your attention to whether there's been performance impacts in your environment. So you can drill a little bit more in detail, and you can easily see right here from the mobile app that there are issues with block latency in terms of performance impacts as indicated by the pink shading, and also performance anomalies as indicated by the blue shading. So what this does is it gives you infrastructure insights right there in the palm of your hand with the mobile app. So logical next steps would be you would hop on over into the Cloud IQ web app. And so this is the Cloud IQ web app. You can see here, for instance, information about the Cloud IQ collectors, the system health, the capacity approaching full that I talked about. And as you keep scrolling down, you see an area indicating performance impacts. And one of the key points I want to make about this is both from that mobile app and here right on the overview page of Cloud IQ is going to make you aware of these performance impacts. So we want to avoid any more hunting for that needle in the haystack. We're going to bring it right up to the top and make it prominent so it's easy for you to know about, so that you can streamline your time to resolution. Let's look a little bit more at these analytics and how they work. So I've now drilled into the storage system. This happens to be a Unity XT. You can see the top talkers here at the top of this page. And as you scroll down, you see, again, just as you saw in the mobile app screenshot, you can see both performance impacts and performance anomalies. Performance anomalies are indicated where, based on the machine learning algorithm that Cloud IQ employs using a seasonality algorithm, that's indicated by the gray, we can indicate for this individual system, for this time of day and day of week, there's been an observed anomaly. We're tracking that over a 3-week period, and so this is an anomaly that has occurred outside the normal range, again, for this time of day and day of week, outside what has been established as normal over those 3 weeks. In addition to that, we have partnered this with another algorithm, a time series algorithm, time series correlation, where we can correlate that at the same time as these spikes in latency, there's been a drop in kind of the inversely related system performance metrics, IOPS, and bandwidth. So with these two algorithms, the Cloud IQ analytics engine can indicate for you, first of all, when there's been an observed performance anomaly, and second of all, when there's been an observed actual impact in the environment. So now we've told you that there is an impact, and so the next steps are what might be causing it. And so this is where the power of context is really important. Right here in the context of this system graph, you can click and drag to then identify what are the storage objects that may be contributing to this performance impact and anomaly. And so, for instance, if you look at this particular storage object, you can see the performance metric there looks awfully suspicious and awfully similar. And so this provides a very simple way to drill right here in the context of what you're looking at the system level to then present that information at the LUN level, the storage object level. Similar metrics now at the storage object level, latency, IOPS, and bandwidth. And as we saw at the system level, again, an anomaly now for this LUN at this time of day and day of week, as well as the same algorithm applied now at the LUN level that we talked about at the system level, where we have a time series correlation where the spike in latency is correlated with a drop in IOPS and bandwidth. So you may be saying, okay, well, that's great, all about storage, but I want to know about the VM. Of course you do. So that's the next thing that we show. So like we did earlier, you can click and drag over the area of interest on the graph. And now, as you saw before, we now go all the way down to the VM level. Again, in the context of that LUN, I can click and investigate further with the VM. Again, using that special Cloud IQ collector I showed you about before, where you can download it right here from the Cloud IQ application. Right here, you can download that collector vApp and then deploy it. Just some real simple instructions right there. All right, so back to this VM landing page. So you can see here the key performance indicators for the VM, the CPU readiness, the active memory, and then the storage latency. Now, in this particular troubleshooting flow, I started at the system level and worked my way down to the VM. But imagine if instead you had chosen to simply search for the name of that VM and arrived at this page. You can click anywhere on the latency graph, and we'll provide for you an end-to-end map that will identify all of the components along the way for that VM. And note that when I click in the pink area where the VM had a performance impact, it will likewise indicate the various storage objects, or storage entities along the way that likewise had a performance impact. So effectively connecting the dots for you to help you, again, understand that performance impact and help you find that needle in the haystack. All right, so we started at the system level. We worked our way down to the VM level. Again, noting you could have reversed that direction. But now the question is, what can be done to remove that bottleneck for the VM? And so in this case, I'm just going to back up a step. That was the LUN that we looked at. If I go back to the LUN page, this was the graph we were looking at a moment ago. You can then see additional details. This is where the workload contention analysis comes in. And CloudIQ will indicate for you where there are other workloads contending for the same resources as the LUN with which that VM is associated. So this is a pretty strong recommendation that if you can distribute these workloads, perhaps to another pool for a Unity system or perhaps a whole nother storage system, then you would remove that bottleneck. You would allow that LUN to receive the resources that it needs, and therefore the VMs associated with that LUN. So hopefully you've seen that end-to-end, in-context, unique capabilities that CloudIQ provides for you to intelligently troubleshoot performance issues in your environment and gives you strong recommendation for how to remediate those performance bottlenecks so that you can remove them. Returning to our presentation, I talked about immediate time to value. All you have to do is install and configure your Dell EMC devices, connect that remote telemetry, including the CloudIQ collector that will bring information from vSphere into the secure remote gateway, and then simply log in and use CloudIQ. Log in to cloudiq.dellemc.com and start using it. You'll log in with your pro support credentials. And I haven't mentioned it yet, but maybe one of the best things about CloudIQ is all of this at no additional cost. We view CloudIQ as an enabler so that you can unlock the power of your Dell EMC devices. So again, log in to cloudiq.dellemc.com and start using it today. To summarize, CloudIQ provides intelligent infrastructure insights by reducing risk, identifying and avoiding issues to expedite troubleshooting, enabling you to intelligently plan ahead by anticipating business needs and avoiding outages, and by allowing you to improve productivity with a single pane of glass across your data center, including your Dell storage assets and VMware. So get started today and start getting advantage with the faster time to insights. Thank you for listening.
Hello, everybody. Thank you for joining for this session today. Today, I'm going to talk about VxRail in the real world. I will share some experience that I have with this kind of appliance. And I will share with you some tips and tricks, okay? Well, I'll talk a little about me. My name is Arla Santana. I am a Brazilian. And so I have more than 20 years in experience with IT infrastructure, especially with VxRail. I'm started with 400 of VxRail. It's an EvoRail, okay? And if you want to learn more about me and access my LinkedIn, have an entire description there, and can you contact me through LinkedIn, okay? And then I will start our agenda for today. The first part of our presentation, we are talking a little about key points of VxRail, and after we are describe some important steps or key points or some tips about the installation, and after install, we have some key points to pay attention, and some tips and some problems I faced during the updating device, and I will share some tips with you, and and some reference and docs to solve possible problems during the updating or during using the device and day by day, during the day by day. Okay, so the key points of VxRail. in my opinion, VxRail is a game changer. For me, it's the best HCI solution. I have some experience with other players, other solutions, but for me, if you use VMware, if you have this free infrastructure, VxRail is the best solution, because the true single pane of glass, you can do everything on the same screen, the vCenter screen, and this is great, because other solutions, maybe you need to go out of vCenter, perform some tasks, return to vCenter. In this case, it's not. This is truly real single panel of glass. You do everything inside vCenter. The interface you are very well customized using on your day-by-day IT administration, IT infrastructure administration. And the other interesting fact is the compatibility, fully compatible with vSAN. Some years ago, during VMworld, I not remember the exact year, I watched a presentation about problems with vSAN. And one of the most common problems with vSAN is about compatibility. The other thing is very interesting about VxRail is the real on-click update. You press on button and everything goes automatically. You know, do you have firmware updates? Do you have vSphere updates? Do you have vCenter updates? Don't worry about these, and the process is very automated, and you don't need to take care. You don't need to worry about this. You don't worry about, okay? And the other interesting fact is the unique point of contact. If you have problem, you just call for one person, one number, and they will solve your problem without need to contact many vendors. This is a great advantage of the HCI, and especially when you're working with a VxRail. Well, now I will share some tips about the installation. The first one is don't ignore the requirements, especially about network and DNS. You need to spend some time planning your installation, and it's very, very important using the SOAP procedures for install. I have experience with more 200 devices deployed, and every installation is a new installation, and every installation do you face different kinds of problems, and many times the problems are occurring because sometimes you're not checking and trying the requirements, especially about the network. Okay, and it's not a problem if you spend some time planning your installation, reviewing requirements. Okay, and really some SOAP procedure, special notes about the installation before you start the installation. Okay, if you are using Dell network suites compatible with smart fabrics, evaluate the benefits of use this feature. Okay, because when you use smart fabric switches, do you not need to configure the switches? VxRail configure automatically the switch for you. This is maybe save time during the deployment. Okay, many people said no, this is not so good. But if you deploying a cluster with a lot of nodes, maybe this is a good idea. Well, it's preferred to use the switches in the mode, not in the stacking mode. Prefer to use VLT if you are using Dell networking, or VPC if you are using Cisco switches or other manufacturers have different names for the same feature. I don't recommend the use of stacking, because when you use Tor switches in the stacking mode, when you need to perform some kind of maintenance, like primary updates, you can incurring on network disrupt and network down, and this is not good. And when you're planning your network for HCI solution, especially about VxRail, we recommend to use two switches. And in this mode, VLT or VTC, they are working independently. But outside, if your other switch looking for this, the other switch see like one switch, okay? But do you have benefits about this configuration? Because you can perform updates without any network outage, okay? VxRail requires some specific VLANs, and you need to configure that before you start your implementation. When you, after you put the device on the rack, you need to cable them. When you are cable them, pay attention in the ports. Don't worry about network interface cards outside the onboard interface cards, because the setup using only onboard cards, okay? And my recommendation for this is using odd ports in on switch and even ports in another, because VxRail that have a predefined network organization, network layout, and if you're looking in the network planning guide, this document you can find during the LMC websites. At the end of the presentation, I will share the address of the LMC websites when you where you want to find this kind of documentation. After installing the devices, after cable the device, I recommend to configure I direct off all nodes first, because sometimes I faced problems. I had problems with some implementations. I remember a specific case, I spent a lot of hours believing that the problem is network configuration. And in fact, the problem was a problem. You need to look at direct console user interface of each node and look if the information about PSMT is present. Some nodes produced last year have a bug with this, and they don't have PSMT identification, and these they not can be found during the cluster configuration. And because of this, I very, very recommend to configure iDirect first. Look if each nodes are health. Look for hardware problems before you start your implementation, in fact. In case of using external vCenter, take a look at VxRail vCenter Server Planning Guide. This is a document because not every vCenter configuration are supported on the VxRail installation. Especially when you use external vCenter Server, you need to check not only the vCenter Server Planning Guide, but support matrix. You need to check if you are using the correct version of the vCenter Server before you start your implementation. VxRail Manager have the full IP address, but I really, really recommend you to change for definitive IP address before you start your cluster building, okay? And for 2-node cluster, I really recommend you to configure a witness traffic separation, a special network, a separate VLAN for this, and take care with you the witness about two facts. The documentation about 2-node cluster is very, very simple. And sometimes you face a lot of the problems with 2-node clusters because it's not so common implementation. It's not well covered in the training for implementation of VxRail. If you perform VxRail implementation course, it's a small portion of the course that they talking about 2-node cluster, but 2-node cluster is a little difficult to put on production because the documentation are simple and not cover all aspects. My recommendation is for this is use the same version of the rules about the vSAN witness. When you download and deploy the vSAN witness, take care with this, because if the vSAN witness has a different disk version than the hosts, you can't perform the deploy of the VxRail 2-node cluster. Okay. Well, if it's happened during your installation, you face this screen, do not panic. I face this kind of the problem in some implementations. In the most of case, just press try again, and this solve the problem. Many times this occurring because some tasks do not perform at the correct time, and because of these, you face this kind of the problem during the implementation. But just press try again. If this doesn't work, look at the log and try to do the task manually. Example, in one of my implementations, I faced a problem with a specific step when the configuring enhanced vMotion compatibility and the installation stopped. I faced similar the screen of this, but I just read logs and enable ransom center compatibility manually and done problem, and the installation, and I press try again, and the install continue, and the cluster was deployed with success. After install, it's very important to rename entities, because the VxRail after the installation has a different names. It's not different, strange names. Not the same. Strange is the best word for this, but many customers, many people want to rename the entities. But my recommendation is look for the solved procedures for this, because not any entity can be renamed. Okay, and the solved procedures are very, very complete about this. They have step-by-step instructions to perform renaming entities. Okay, enable vSAN performance services is very important too. Enable Skyline, the online health check. I recommend this because before you enter in production, the environment start production. This is very important. You make a health check of your cluster using the online option. If you want to use the duplication, compression, and encryption, this is the time before you put the device in production. Because when you activate, when you enable these features, it's necessary to reformat the disks. And this task is time consuming. And the other thing, during this task executing, you have limited availability. Because of this, I recommend, and after install, before you move your workloads to the new cluster, enable this. Okay. And the other very important step is enable ESRS, the call home function of the VxRail. And this is not only used for problems. Recently, we have ACA as an analytical consulting engine. The data transferred by ESRS I use it for analytical consult engine. Analytical consult engine is a very new feature introduced last December. And it's very, very interesting because this feature provides information, analytical information about your cluster and perform updates. When you perform updates, I prefer, for my experience with a lot of implementations, to use offline bundle and the internet upgrades, especially when you are deploying more than one cluster in the same organization. Maybe this is a strange scenario, but it's not so strange for me because we have a limit on the standard cluster of 64 nodes, and sometimes some companies work with 2 or 3 clusters, and sometimes when you need to deploy more than one cluster, you need to do that. Download the offline bundle and perform updates faster than you use the internet upgrade. Okay. If you found errors during the upgrade, don't worry. Don't worry. Just press try again. It's most cases enough. Okay. And I performed installation here in Brazil and in a customer, a lot of 2-node clusters in remote regions of Brazil. And some regions don't have good power sources. And sometimes during the update, I face a power outage. Okay, don't worry if it is occurred because you just power on the solution again, and the update continue. Okay, very, very rarely you face a problem that you need to contact support to solve this kind of problem. And if you face some error during the upgrade, please look the log. Sometimes the log have more information, more detailed information that help you to solve the problem. Well, solve the problems before you can contact the support. Okay. Before you contact support, take a look at event code reference. And this, I put some reference here, just 2 links because this documentation changes every day. And just put two links. The solve online. The solve has a lot of procedures step by step. And the InfoRub. InfoRub is an entire documentation about VxRail. So for today is this. Thank you for your time. And you have doubts, feel free to contact me. Okay, thank you.
Hi, this is Milind Halpet, Global Cloud Practice Vice President with vTechTalks. And today we are going to talk about how do we provide a consistent experience from cloud to edge with boundaryless data protection solutions. Next slide, please. So when we look at the cloud trends, the reality today is, the cloud spends are going to go from 260 billion per year to almost 927 billion per year. At the same time, we see enterprises embarking on the digital transformation journey, and the adoption of cloud across enterprises are accelerating. And this actually points to one outcome. The volume of data that is getting generated in the enterprises are skyrocketing, whether we look at data that is structured or unstructured. And at the same time, organizations are going through certain challenges. IT needs to do more with less resources. And at the same time, data protection is at the center of the entire transformation. Anything with respect to the data protection issues that may lead to revenue loss, it may lead to brand problems. So it is actually a critical problem for any enterprise to solve. And when we look at some of the common investment priorities. In fact, data protection is the number one priority across the enterprises. Enterprise needs to manage the data lifecycle management all the way from the backup, retention, disaster recovery, archival, and long-time retentions. So with this backdrop, I would like to move to the next slide where we'll deep dive a little bit into the solutions. Just a little bit of background about our partnership. Wipro, Dell, and VMware have a solid partnership going on for decades. With a very rich system integration, transformation, and managed services experience, Wipro has been innovating in the market along with the Dell to release the cutting-edge solutions to the market, along with VMware as well. These solutions actually span across data center to cloud to edge and to the end-user devices. And some of the most important considerations while we talk about the solution sets is, do our solutions offer lower cost and high value? Does that actually integrate with the other ecosystems within the enterprise? How automation becomes an important tenet of the solution? And finally, these solutions have to work seamlessly. So are our solutions